Get started pretty soon. Welcome everyone back to the workshop for the final day. In the morning, we're going to be talking about length-based dynamics. In the afternoon, we're going to talk about more about how we go about implementing the model and all the different logistical things we have to deal with to do that. And then after that, we'll have a final discussion, wrapping up maybe what we've learned and maybe deciding on a few things, or at least initially giving ideas about what the general model should look like. So this morning, Andre's going to give us the first presentation, which is a review of including length-based dynamics in stock assessment models. I think we'll wait a couple of minutes just to allow the attendees to join the meeting, and then we'll get started. So, Andre, you want to try and share your screen, see if it works? Okay, we can see it not in full screen yet, though.
It should be there.
Yep, that's full screen. Looks good. We can hear you and see the presentation. Okay, Andre, might as well get started.
Okay, Thanks, Mark. Thanks for giving the opportunity to chat about age length models a little bit. Sorry I can't attend the meeting at the rate I would like to, but apparently we have to do what pays our salary rather than what we enjoy, and in my case, it is grading. So if you felt that you were depressed about life, I can help you be more depressed by seeing what undergrad students think of statistics. Mark asked me to give a sort of introduction to age length-based models. This is actually an interesting topic in the sense that it's one of those things that sort of pops up regularly in the literature. Everyone's thought about it, but it never seems to quite take off. And maybe we'll hear from Gadget that, Gadget is the 747 that has actually taken off. So as I go through this, you'll sort of see some very familiar names and concepts. And my aim for today really is to introduce these models and talk about some of their advantages and disadvantages. And in particular, Mark sort of indicated to me that it would be important to talk about some of the challenges associated with these models, and in particular, the computational issues. So many of you will recognize this picture because you're in it. This was our CAPAM best practices workshop that we held in Rome a couple of years ago. I'm not even sure what year it is anymore. I gave a talk, and the rather pathetic table on the right-hand side of the slide indicates what were the sort of things that I thought were important in terms of the decisions you need to make when you are designing a stock assessment. And you'll see that the first of those items, very conveniently, was what is the correct population dynamics model? And that particular question feeds into Several of the other questions, in particular the second question, which I won't be touching on in much detail, but is definitely related to population model. So let's delving down a little bit in terms of what do we mean by the structure of the population dynamics model. The focus for today, at least from me, is going to be the N matrix itself. So how do we model numbers at age as a function of time and other variables? Related to this topic, of course, is these other questions which feed into both the definition of the model of the population dynamics and also, and I'm sure you'll talk about this afternoon, some of the computational aspects. So in particular, spatial structure adds computational demands very, very quickly. And I'm hoping that what I say today is sort of related to what I said when I gave my keynote in Rome however many years ago. But knowing me, that's certainly possible. I've changed my mind completely. So to sort of put some context here, and because we have to have equations in these talks, let's just make sure we're all on the same page as to what is meant by an age-length structured model. And so in order to do that, I'm going to contrast the sort of three main categories of model that we use in stock assessment. The first of those, and my mouse appears to be moving at a speed which is slightly slower than I can see it in my screen. So the simplest form of population dynamics model is our standard age-structured population model, where we only model age structure, and if we need numbers at length, which we often do when we're fitting to length frequency data, we essentially make the assumption that we can break the numbers at age into numbers at age by age and length, and then sum over age to get numbers by year and length in this case, and any other breakdown that you might want, sex or spatial structure, etc. But the key point here is that you're keeping track of ages, and length is sort of a freebie that comes on later on. And models such as stock synthesis are really based on this structure. Length structured models, I don't know to what extent this has really even come up during this workshop. Length structured models are the models we tend to use for populations for which aging is difficult or impossible. And the key point here is our N matrix now has dimensions year and length. Age has vanished, and we only we model population dynamics using essentially stage structured dynamics, where the numbers in a given year class are, for all intents and purposes, the numbers moving into that year class having survived total mortality. So no reference here to age whatsoever. And then when we get into the models that I'll be talking about, is the models that really are focusing on age length dynamics. So the N matrix has now generalized to have age and length. And the way I've modeled this, and I'm intrigued to see how other people have done this, and this is the way most of these age length models work, is growth is modeled rather like a length structured model, where we model the transition probability between length classes. So in this case, this is the probability of surviving in length class L dashed and growing to length class L. This particular formulation assumes that growth only depends on current length. One can generalize that so that growth depends on age and length. You can calculate all the usual things that we do in stock assessment models. So I've just given one equation here, and that is the catch as a function of fleet, year, age, and length. So this is your standard catch equation. In this case, I've got retention and selection brought out explicitly. But essentially, one can calculate all the usual sorts of things that we have in our model fitting procedures, whether that's retain catch, conditional age at length, marginals, just lots and lots of sums over dimensions. So when we think about comparing age and length structured models, initially, I'll come to age length models in a moment. I sort of covered several of these things, and I'll delve into some of them in more detail in a moment. Obviously, the key thing about age models is that they're age structured, so any reference to length is going to be approximate, as I showed in the previous slide. Similarly, for length structured models, we struggle to deal with anything to do with age dynamics. As I'll cover in a moment, one of the disadvantages of age-structured models is that depending on how you set them up, we often ignore changes over time in length at age distributions, and I'll get into the Rosalie phenomenon in a slide or two. The growth obviously differs in how it's modeled. One of the challenges, particularly that you guys are going to face in the Tuna world, is tagging data. When we're dealing with tag data, tags are usually quantified by length, not by age. And so with an age-structured model, you need to work out how do you assign animals that have a particular length to age. And if you're estimating growth internally to an assessment, you've got to do that dynamically. In terms of speed, there's no doubt that age-structured models are heaps faster than length-structured models, simply because you're not dealing with the complexities of that X, the size transition matrix. And for those who care of packages, length-structured models, while there are some packages in development, they're really few and far between. When we get to age-length models, everything seems like it's a lot better. Now we're keeping track of age and length dynamics, so we don't need to worry about or at least not as much about dealing with processes that depend on age or length. I'll show you in a moment that age-length models deal very explicitly with the Rosalie phenomenon and with truncation of length and age distributions. We can have generalized biology and selectivity. There are really no problems now with assigning tagged animals to length because the model is length structured. I'll show in a moment that simulation studies have shown that, at least in some cases, there is less bias, estimation bias. And as I've shown in some previous work, which I won't be able to get into, it's pretty easy to simplify an age-length model to a length model, less so actually to an age model itself. There are, however, some challenges. One in particular is that these models tend to be much, much slower than age or length structured models themselves. Just setting them up, the initial conditions can be quite complicated because you've got to calculate numbers by age and length in the first year. And I think we'll be hearing from Gadget in a few seconds. I put published in quotes. I'm sure Baki will disagree with me, but I don't believe I know of a peer-reviewed publication that documents Gadget, so I'm encouraging him to publish in Fisheries Research, of course, but that's just me. So let's sort of get into some of the core details here. I'm illustrating something that is very well known in the ecological literature. This is referred to as the Rosalie phenomenon. Essentially, let's think about a population. Hopefully my mouse is visible. On the right-hand side, we have a length at age distribution. This is for a cohort where there is size selective fishing. So if we fish down a population, if the fishing mortality is higher on the older fish, you would expect to lose some of the right-hand side of this curve. So the black line here, the black line is the population length at age distribution. You can see the black line down here is after fairly high fishing mortality. The black line is truncated on the right. The dotted line here is how we would model length at age distributions within, say, stock synthesis. And you'll notice this difference between the black and the dashed line. That's the assumption in many age-structured models that the length at age distribution doesn't get truncated. It just recreates. I also show some red lines here. These are platoons. I don't know whether there's a platoon talk coming up. One of the approximations, which I'll talk about later on, although I've only got a few minutes, is how do we simplify these models using, for example, platoons. And platoons can capture the length-specific selectivity to some extent. So Rosalie phenomenon, I think it's important that we think about that in the context of these age-structured models in particular, and how length at age models can fix this. It's fair to say we've known about this for a long time, and the simulations that have been done by people like Rick McGarvey and Rick Mathot have shown that it can lead to bias and estimates in particular of growth parameters, and that's to be expected. But really the key thing is, for most of this work, that the fishing mortality has to be quite high for this Rosalie phenomenon to be quite large. While people have thought a lot about the Rosalie phenomenon itself in terms of growth and changes in length at age distributions, I think it's important to consider the Rosalie phenomenon, if we want to call it that. Maybe it's the Rosa-Maunder phenomenon going forward. And that is that when animals move between regions, we tend to ignore the fact that perhaps different ages or lengths are more likely to move, in particular age length groups moving spatially. So when we think about spatial models, age length models may have an important role to play. People have compared age length models over time. I did a very quick review of this, and the number of simulation studies is increasing. Most of the simulation studies suggest that moving to age length models will reduce bias in estimates of management-related quantities. Obviously, it depends on how much data you have, and in particular, how you set your model up. So depending on your model assumptions, you can lead to substantial error. So in terms of parameterization, when we move to age length models, most of what we are used to in stock assessment, particular age-structured stock assessment, remain. They change over pretty straightforwardly. The two things I want to emphasize here is modeling of recruitment. What is recruitment in particularly a length-structured model? Usually we don't model age 0 explicitly in assessments of, say, crabs or prawns, but we model from a size class. One of the advantages of age length models is that because we have explicit age, recruitment has its normal age-structured interpretation. Focusing again on growth, as I say, in most length models and age length models, we're modeling using a size transition matrix rather than, say, using the sort of growth curve approach that that we would normally see in synthesis. I'm not covering in this talk the idea of empirical weighted age, which begins to play a role in some of these models. But to date, most of the models that I've seen haven't used empirical weighted age within the context of age length models. So moving in terms of data structures, we do have the ability within age length models to deal with all the usual data types. In particular, we have the ability to deal with changes in length distributions and to deal with tag data a little bit more naturally, simply because we have lengths as well as ages in the population dynamics model. For most of the likelihood components, however, the likelihood components for an age length model are essentially unchanged from what you'd be familiar with in standard age or length structured assessments. Okay, so that's all very nice. However, the question really arises is, can we implement age length models sufficiently efficiently that we can have age length models being the routine way to conduct stock assessments? And so what I do in this next section of the presentation is really to ask the question, what are ways to simplify age length dynamics and to approximate age length dynamics using simpler model formulations. So the two that I am most familiar with are platoons, which is a feature of stock synthesis where each cohort consists of multiple platoons, usually 5, and those platoons essentially act as subpopulations or sub-age classes within the general population model. There's an alternative approach developed by Rick McGarvey and used in South Australia, I think still used in South Australia, but perhaps not, is called SLICE, which essentially was built around the idea of knife edge selectivity, which was something that the South Australians dealt with. Rick and several of the people on the call conducted some simulation evaluations of these two methods using an individual-based operating model, so an operating model that was neither of the two approaches and was essentially an age length model. And what we found, not definitively, but pretty strongly, was that platoons actually led to fairly unbiased estimates and certainly outperformed the SLICE method. So if people are thinking about a computationally efficient way to calculate, account for age length dynamics, doing it through the framework of platoons seems like a good, at least short-term solution while we improve our computational efficiency. So just to remind people what platoons are, it's a slide I pinched from a talk by Rick Mathot. So the top panel here shows a single cohort with its mean size, and in this case, the green lines are the platoons within each cohort. And the point here is that these platoons evolve over time with the consequence that you can fish down some of these larger platoons, assuming that selectivity is increasing with size. What it means is that the length of age distribution will change over time, just like an age length model does. And unlike conventional age structured models, once you start reducing fishing mortality, the age length distribution will start to return to its quote unquote unfished level. So it has much of the dynamics that we need in age length models, but without the complexity of having to deal with large scale length dynamics, which can definitely speed up the calculations by doing this. That said, simulation studies of age length models, and I'm hoping Bjarke is going to disagree with me and tell me I've just missed the literature, have not really been that extensive. There have been some simulation studies looking at what happens if you apply age length models to, age models and length models when the operating model is age length, and in general, you end up with bias, but that bias isn't necessarily completely removed by the adoption of age length models unless the age length model is correctly specified. So the problems of model misspecification do not disappear in the absence of by moving to a more complex model. So sort of delving a little more deeply into how we can think about efficient ways of coding age length models. The key thing that causes the slowing down of these models is keeping track of the age length dynamics. In the past, these models have been at least an order of magnitude slower than either age or length models. That said, with faster computers, we're now getting to the point, this is a paper by Zhang and Cadigan, where they implemented one example of an age length model using, in this case, TMB, but you could do the same thing in RTMB. So we are getting to the point where it's possible to routinely apply these models and even simulation test them to some extent. we need to also think about simplifications. And some of the challenges that we want to reduce is having very complicated N matrices. And so I'll show you in a moment a model developed by Simon Delastang, who either is on this call or probably is asleep actually. But he gave a talk, I think, yesterday and I'll show you some of the aspects of this lobster model that we're developing, where basically what we do is we have many length classes, but actually only a few age classes, only as many age classes as we need to represent the dynamics or the aspects of the dynamics that depend on age. The other thing that, and again, Simon might have touched on this as well, that becomes very challenging, and anyone using multifan CL or similar techniques will be aware of this, is the computational burden of many tag groups. So if you've got many tag release events, that will really affect the speed of any age length model. So I have no solutions to that, except thinking really strategically if we want to run these models in sort of real time, how we deal with multiple tag groups and maybe aggregating over tag groups a bit more than we have in the past. So here's Simon. I don't know if you saw him yesterday. So he and I have been developing a replacement model for rock lobsters in Western Australia. And we've developed an age length model in TMB. The first attempts to run the model we had the feeling that it was running slower than real time, which was disappointing. And in order to speed up the model, what we ended up doing, and I think this is worth thinking about, is only modeling a couple of age classes. So for rock lobsters in Western Australia, there's some age dynamics, in particular movement, that depend on age, but only for a couple of age classes. So we've got a model that fits to most of the usual data that are available for rock lobsters, including tagging data, but it only captures a few age classes so that we capture the necessary dynamics, not all of the dynamics. And that has actually allowed us to get to the point where the model is almost operational. So I need to apparently stop. I have, believe, 3 minutes. So a couple of things to highlight before I stop. The first one is just really thinking about the coding and making the matrix algebra side of things in these models as efficient as possible. Everything that we've done with these models suggests that most of the computational time is updating the N matrix because of the length dynamics. The other thing that crossed my mind as I was preparing this talk was diagnostics packages, and what I haven't thought about, and I don't know if anyone has, maybe again Gadget has more than anyone else, is the additional diagnostics that we need to think about when we're applying age length models. Most of the diagnostics I've used in my work have arisen from length structured models or age structured models without really thinking about what's the additional work needed to create diagnostics for age length models. And with that, and 2.5 minutes to go, I will stop and take questions.
Thanks, Andre. Anyone got any questions for Andre? Darcy.
Yeah, good morning, everyone. Thank you, and thanks, Andre. I guess one thing that I've been thinking about this a lot lately and working on an age length model myself, and it occurred to me that it might not be the case for you where you've got very few age classes, but in other models where you've got lots of age groups and lots of length bins, you tend to end up with sparse matrices, which has meant that you can actually start to lean on the sparse matrix algebra. And I found some of that stuff sped things up a heck of a lot. So, that's something to keep in mind, that they might seem slow to start with when you use the clunky old code, but when you move into that stuff, it speeds things up quite a bit.
Yeah, that's absolutely true. And I haven't got terribly into the sparse matrix stuff. When I was developing a prawn model, which makes age length dynamics feel horrible, because if you thought your models took a long time when you got a weekly time step, it takes even longer. And one of the challenges there was we were trying to estimate growth as part of the calculation, and which entries were sparse depended on the estimation of growth. So if you're estimating growth internally, some of the, not necessarily at the end of the calculation, but during the minimization, you can go through matrices that actually don't look very sparse, at least, as a function of age and length. So I agree that needs to go, but I think you need to think quite carefully about how that deals with internal estimation of growth.
Nick, you have a comment? Question?
Yeah, thanks, Mark. Thanks, Andre. That's a really good overview. Just a comment there related to speed. Yeah, certainly multiple tagging groups are a real headache for WCPO Tuna. In the case of Skipjack, currently the assessment's got more than 300 individual release groups. But I'm sort of hoping that there is some scope for using the OpenMP capabilities within TMB and RTMB to try to address this in multi-thread operations within the model evaluation, which can be readily parallelized. Dave did do some prototype exploratory work with this within Multifan CL and was able to parallelize to a certain extent the tagging program populations. And I think I mentioned it on Wednesday, that it did significantly improve the speed. So with careful programming and using OpenMP and sparse matrix functions, one may be able to make an age size structured model more feasible. Thanks.
Yeah, I mean, and the other thing, and this goes to the model that we've developed for Rock Lobster, is some of the tag processes are going to be length only. So for example, if you're only using age models for movement, but all your tag dynamics are in length, in principle, you don't need to track as much of the age. You don't need to keep you don't need to model the tag population necessarily as age and length. You can model them simply as length. So again, it's a question of trying to be strategic of how we simplify the N matrix, whether it's sparsity or not tracking quite as many things as we've traditionally tracked, or just buying faster computers and using better coding.
So, Andre, I got a question for you about the platoons.
Yep.
Obviously, there's not a lot of data to set up the platoons and things like that, so there might be problems. So, if you misspecify the variational length at age, does that cause the platoon method to be highly biased?
Well, firstly, there hasn't been an enormous amount of simulation testing of platoons to this point. Rick and Ian Taylor probably did the most of it. We did a little bit. The length at age distribution itself, so you're like I guess you'd call that the CV of length at age. Mm-hmm. That is indifferent. It's essentially you can think of let's just work with variances. The variance of length at age is the sum of the variances of each of the platoons within the platoon structure. So it's really between platoon variance and within platoon variance you're trying to parse. And I certainly don't know off the top of my head what sort of error you're going to do if you get that split wrong. So I wouldn't be worrying about length at age variability. I think that's the same problem we got whether we do platoons or not. It's how you split the variance of length at age within the platoons and between the platoons. So that's how many platoons and where their means within the cohort, and then how much variability there is. Ultimately, those two need to sum up to the total variability. But I don't have any data on how much bias you could get. Rick suddenly appeared.
Just to clarify the question a little more, is you often, if I get it right, you often approximate it by putting platoons equally spaced, and and then you get the platoon distributions to match the overall distribution. But if you put if you had the variation length at age for the total distribution wrong, then you end up getting a couple of platoons that might get hammered by the fishing mortality that are actually not really there, and then you would end up getting a big bias, right?
I don't know if that bias be worse than just getting your length and age distribution wrong in the first place. So I just don't think we know enough to certainly you'll get some bias. The question is it worse bias than the bias you would get just ignoring it completely? And I don't think, at least I don't know, maybe Arnie does, and it's good to see Rick, who's actually developed the approach right in front of us.
Yeah, Mark.
Okay. If you got a quick answer to that, Rick, before we move on to the next presentation.
Yeah, we did look at that, and I found out that you actually can estimate that variance if your data are informative. Well, when are your data informative? It's when you see a pattern of declining mean size at age over time is information about the strength of the phenomena. And so that allowed us to figure out that the parameter that controls that ratio is potentially estimable. And so, that also led us to coming up with what is a reasonable prior on that parameter given that. Now, this is something that from detailed information about the degree of within cohort variation you have, within the individual variation you have in growth trajectories, that actually could be tapped into to develop some information about, well, what do you expect? What is the degree of inertia in growth trajectories versus things that are going to be just a variation on those growth trajectories.
Yeah, thanks. Okay, let's move on to the next presentation. And I think it's Bjarke, if I get it right. Yeah, so Bjarke, can you share your screen?
Yep, will do. What's this one? Do you share my screen? No.
Not yet, no.
Is it coming in or?
No, that's it, yeah. Oh, here it is.
There's something coming.
Yeah.
So do you see my screen in full, my presentation in full screen now?
It's in full screen, yeah.
Okay, brilliant.
Yeah, thanks.
So thanks for the opportunity to come in. Just to answer Andre's comment, there is actually a paper on the way. We're just working on or Jamie has been working on a manuscript that we are hoping to get done in the early part of next year. So stay tuned for that. But today I was going to talk about the length-based processing gadget, how that's done. So I think the presentation we had from Andre is a nice precursor to what I'm going to show you here. So just to give you a small sort of background on gadget, if you don't know it, it traces its origins quite far back to the 1990s. But we started work in the late sort of around 2020 on Gadget 3, which is a new implementation of the concepts of Gadget with linkages to TMB and R. So it's so basically now Gadget is an R package that you can download from CRAN, and it's an environment to build the assessment models and mice models entirely from R. And it's easy to adapt the processes, or so basically it's a toolbox of processes, so you can easily adapt it to do whatever you want, and also you can plug in different processes and modify them yourself. So I'm going to give you examples of that later on during the talk. And also, given that this is an age length sort of modeling tool, you can flexibly add observation data whenever it's available, and I can show you sort of slightly how the interface looks like. And it's basically it covers all the old concepts of Gadget, but it also now allows for random effects and sort of other things, courtesy of TMB. And of course we tried, and the main objective is to be more flexible than the old modeling framework was. Sort of key concepts. It's sort of, you have stocks which can be either length-based or age-based or age and length-based. You can And you basically, when you set it up, you define, which you can see, sort of simple code here on the side here, allows you to set up the dimensions and the names of the stocks, which is useful to then when you're comparing with the data. And you can specify the dimensions both in terms of size and age. And in this sort of convention, fleets are actually a special instance of stocks. And on the other side, then you define a list of actions that affect the stock objects. So this would be growth, migration, aging, stock interactions of various sorts, and whatever you can think of. There is no restriction on the numbers of actions. Just the only restriction is actually the computing hardware that you have, the amount of RAM and CPU time, and et cetera, et cetera. Now, data is basically just added whenever you have it, so it's a very flexible thing. You just define a list of likelihood data, and the aggregation is actually deciphered from the data set itself. So it's basically you pass a data frame into the likelihood function, and from there it can decipher if this is an age data set, length data set, or age length data set, or survey index, or depending on how you set it up. Now, length in Gadget, it is sort of following the same sort of type of nomenclature, sort of formulation as shown earlier in the presentation from Andre. If you assume that you have an n matrix with and the n's here are actually length, so the length per cohort, per age of the cohort, and at a certain time point. And then you specify the length transition matrix, which can be cohort specific. And of course, then you have the recruitment coming in at a certain point in time, and it has that has a size distribution coming when it comes in. In Gadget, there is one way to disperse to parameterize this growth transition matrix, and it's basically the entries in the growth transition matrix follow a beta binomial, or sort of the beta binomial density, and where the mean comes from a sort of a mean length update, length update, which the user can specify. So it's in essence you tweak two parameters here, which is the maximum length group growth, how many length groups growth you want to add to the sort of how many length groups you're going to be working with, and in the length update, and then you also specify the beta, which allows the sort of defines how the kurtosis and of the size distribution at age. So here's an example of when we for a normal length for Bertalanffy length update, which is, well, it's been written as a sort of length-based version of the von Bertalanffy growth. And here on the side here we see the sort of example of how when the population is unfished, how it progresses from age 0 all the way down to age, I think, is 15 in this plot. And the dashed lines here show and solid lines show the different values of the beta parameter. There is multiple options for this mean length growth. There's also one which depends on the consumption of the species and temperature, but there's also a way for the user to define its own function and just plug it in as I said in its place. And also there is a way to modify parameters, which I'm going to show a little bit later. And this allows but because we're tracking the numbers at length and age, you can see the sort of the Rosalie effect in the if you have very heavy fishing on the fish stock. Now, the implementation is basically you have you specify a growth action, and in essence you have the beta binomial growth action, and then you have a mean growth update, and the function is basically this is just sequence of R functions, which are then which you usually can modify by itself. So this is fairly easy to replace with whatever you want it to be. And then when these actions are all then compiled later, it will be transliterated into TMP code. But there is also so this is one avenue of customization, but there is another avenue of customization by gadget parameters, which is a parameterization that you can do sort of whenever you specify model parameters. This is actually you can either specify them to be constant through time or time varying. And here's an example of how you would do that. And here are some random values that I assign to the K parameter in the von Bentonaffi growth curve. You can also have the K dependent on external data sets. So for here example, if you have temperature by area, you can specify it like that, and you can see there will be an effect on the growth. You can also have density dependence in growth. So as the fish population within an area is bigger, then you can have the growth dependent upon that. So you can have a reduction in stunted growth as the density is bigger. And also you can add random effects to all of these things. And basically you would set up a parameter like that, and this will give you this will tell that this epsilon here is a normal, it would be normally distributed. Just to also give you a quick example, that we do have this we have used gadget to assess a stock where there was very little age data. So, and we use that for the purposes of advice for blueling in Icelandic waters. And it's a very long-lived species and also but data poor, so we have very few samples from our commercial fishery. Thankfully, we have a little bit more from our surveys, but it's very hard to age read. So, and we have none from Icelandic waters. So the model could happily fit to the data because we had these large gaps in the recruitment. So we could see it in our data, the size shifting further to the right. But since because of the lack of the age data, the estimates, terminal estimates of sort of spawn stock biomass estimates and all that, they were very variable. You can see it here in the MONS, sort of the analytical retrospectives and as estimates. And so we did try to push information or use information from adjacent stocks to calm the information. So it is quite even though if you don't have information on growth, you need to often you need to add information from some information on growth to stabilize the models and stabilize the model to the correct or sort of stabilize the model estimates over time, even though the fit to the data is fairly similar. Now, just to conclude, so I mean it's a fairly flexible parameterization that we have, and it's fairly straightforward to modify the growth functions that we have in the model. But as Andrea alluded to, it's fairly computationally expensive. I mean, it's all order of magnitude more expensive or sort of order of magnitude slower to run an age length model compared to an age only model, as the growth is applied to each length cell. The So a typical implementation, like the Blueling that we saw earlier, has about 50 length groups and 50 length groups and then 15 age groups on quarterly time steps. So that's quite a lot of calculations that are needed to update the numbers at age and length. And this is in this example, I think we were looking at sort of 15 to 30 minutes to optimize this sort of very basic model. You could reduce the numbers that we can reduce the as André mentioned, if you reduce the number of age and length groups, it will definitely have an effect on the runtimes. But when you start using random effects, it really adds to the calculation overhead and the memory, especially the memory overhead. So it's only feasible to run it on computers with more than, at least the Blueling example that I had showed earlier was only feasible to run on with 40 or 50 gigabytes of RAM. And it's obviously it's possible to fit without age data, but information on growth is definitely helpful. Some information on growth is definitely helpful, and we are also looking into trying to figure out how to make this a little bit faster, but especially looking into sort of when, at least in the context of multi-species, it's definitely worthwhile to try to figure out ways to reduce the number of size groups. And so there are possibilities to set up a fairly detailed sort of key species, and then which could predate on species which you only model as a surplus production type of a model, and also you can also have age only models, and you could also have age only models in for certain parts of your models. Yeah, and here's a couple of links, and we also want to acknowledge some of the funding sources that we have had. Thank you.
So I have a kind of clarifying question. You said that you could estimate the model parameters even with length frequency data, but I'm guessing that was in the Ling model or something like the Ling model, where you had a long-lived species that had big spikes in recruitment, so you could see the cohort going through, and that's where the sort of the age of the growth information was coming from.
Yeah, pretty much. I mean, if you look at the survey length distribution samples that we had, was because of this long period of very low recruitment, you could see the size distribution shifting more to the larger fish, and I do think that it definitely helped with the model estimation. So I would think if you at least that's been my experience with a related species which had a bit more even recruitment, is that the level of the biomass really comes from the information on growth, and it doesn't need to be that much, but it definitely needs to be some amount of data that comes from that.
Okay. Anyone else have any questions?
Yeah, Mark, this is Rick.
Okay. If we don't have any questions, Rick, do you have a question, or we can't hear you?
Okay. Have you given thought to the problem of birth date distribution? Not all fish are born on the same day, right? They're spread out sometimes over months. I have a feature in synthesis to deal with that, but haven't really had a chance to explore how to make it operational. So essentially, fish that are born early in the season have a head start, and that produces an effect where by the end of the year, you have a distribution of size and age that is contaminated by the spread of birth dates. And that also means that even though all the fish have the same K and the same L infinity, they have a different T0. And so at a given time of year, when they're young, they have a broader effective size and age distribution than as they get older and they start working towards converging towards their final. So, I've built a mechanism into synthesis to deal with it, but no, I've never had a chance to really explore how you use that in an effective way, because I think that is actually a significant source of the variability in size and age that we see.
Yeah, good point. In Gadget, you can set this up as different stocks. So if you had, or you can have different recruitment events.
Yep.
Right. So and you one way of doing this would be you'd have different recruitment events, and then they would effectively have the same growth process, but the ones that recruit earlier, they would have different they would just be larger at a certain time point. If you specify them as different stocks, you could also, the aging could occur at different time points. So for example, because we have time steps, intra-year time steps explicitly in the model, you could say that the birth date is not the 1st of January, it's maybe the 1st of May, for example. And then the aging could, so even though these would be sort of, these two stocks would share everything except for the birth date, they could, so this could be achieved by doing something like that. And I think actually we did this for anchovy in the Bay of was it Bay of Biscay? No. Jamie, what's Margarita's stock?
I can't remember either.
Yeah, it was anchovy in the southwest of Spain, which where they had basically continuous recruitment. So we had to you basically have estimates continuous recruitment throughout the model, and the fishing. I mean, it's a very short-lived species as well. So.
Okay, thanks. Let's move on to the next presentation. So the final presentation for lengths-based dynamics is Nick. Can you share your screen? Okay, we can see it. It's in full screen mode.
Okay, thanks very much, Mark. Can you see that and hear me okay?
Yep, everything's good. So go forward.
Good. Thanks very much. Yeah, thanks to Arnie and Mark very much for inviting me to contribute to this. It's a really significant meeting. In this item, I just thought it'd be useful to review the basics of several model structures and just to compare them in terms of their capability of dealing with length-based processes. And I'm going to focus specifically on growth and also spatial variation and growth and the implications of that in respect of fish movement among regions. So yeah, I'll give a brief overview of each of the three same model structures that Andre talked about. And I just want to acknowledge Kuan, who was a great help in putting together this presentation and who has done some really good work on this area together with Philip Newbar in recent years. And also I'm going to show my age here. I'll just get my laser pointer. Yeah, so going back to this symposium in 1997, where they were reviewing stock assessment models for the 21st century. So nearly 30 years ago, we were already on the track of trying to look at where we're going ahead. So I think some of the references in my talk are going to go back to this, and we're pretty much standing on the shoulders of giants here with the excellent work that's still inspiring that came out of that meeting. So firstly, I think it's important to standardize on the terminology and acronyms because there's a lot of these things going around. Everyone uses a different acronym for an age size structured model. And then I'll quickly review the various available structures and how they're formulated for dealing with the types of growth variability and spatial variation in growth, and finish up with a bit of a context for the WCPO and a recommendation. So I'd like to just use the terminology similar to that of Alan Axelrod and Andre's simulation studies to be convenient. So we have the age-structured platoon model, which is we're all familiar with stock synthesis, the size-structured model, the age-size structured model, and I'll be talking about 4 of those. And I'd also like to use this really nice term from Ian and Rick's paper, repeated regeneration, which Andre mentioned, which is the necessity to update a cohort's length at age distribution with each time step. So the acronyms we have are these. This is the length-based assessment model, an acronym used by CAPAM, and it's based on the growth function that Terry presented back in 1998. And these are the 3 age-size structured models, one by Fan and Knoll, and Keown and Phillips, LAM, and then the Kalin model, which Dave Gilbert, myself, and Jeremy developed a very long time ago. So yeah, starting off with individual growth variability, and I'm just going to repeat a couple of things which Andre outlined. So with the age-structured platoon model, I'll just say that the way that individual growth variability is modeled really depends upon the model structure. So for the age-structured platoon model, we have a mean length at age with a variance around it, and that's used to create an age-size distribution in a particular time step. Whereas for the size-structured and age-size-structured models, it has this length transition matrix, which has been mentioned in the previous 2 presentations. So as Andre stated, you take this for the age-structured platoon model, your mean length at age with its variance to define a distribution. That's applied to your state matrix, and that gives you, for your platoon, the age-size composition in a particular time step. So this, the caveat here with this method is that growth is age-based, and it really requires this repeated regeneration with each time step. Now, the platoon approach, as we've seen, is a really good approximation for capturing Rosalie's phenomenon, or what Ian uses in his paper, he calls it selective mortality effects in respect of length. For size-structured and age-size-structured models, as Andre showed, the population state matrix is in terms of age and length. So in this sense, this matrix allows one to conserve the effects of length-based processes on a cohort size composition between time steps. So there's no requirement for repeated regeneration. Anything that happened in a previous year is retained when the population is updated to the following year. So that length, that whole Rosalie's phenomenon is naturally encapsulated within the state matrix. And so for the size structured and the length and age size structured, you have this length transition matrix, which is discretized over the size class intervals for your model to give you the probability of a fish of a particular length advancing to a new length. So it might look something like this, which is what we estimated. The caveats of the way this is used in most age size structured models is that the length transition matrix is time invariant in some of the examples we've seen. And the key thing here is that it applies to all ages within a length class. And I'm going to come on to that in the next slide. And of course, we have the issue of it being computationally intensive. So now looking more closely at the age-specific effects on growth. So with the size-structured model, this is impossible because the age dimension is completely absent. Naturally, age-specific effects should affect individual length-based growth variability. individuals of the same length but of different ages may not necessarily have the same probability distribution of advancing to a new length. So having an age-specific growth effect allows for the condition of dwarfs and giants, or where for a particular length interval, the young fish in that length interval will tend to grow faster in respect of their lengths than older individuals in the same length interval. Or that fish that have got ahead of their year class will tend to continue to grow faster than their equally sized or older peers. So in the CAPAM model, we were able to achieve this effect by means of a couple of covariates in respect of the length of a particular age length cell within that matrix. And estimating those covariates really did seem to improve the AIC of the model fit to the data. Perhaps a better approach is that developed by Kuan, which builds on the work of Terry back in 1998 that uses the Cohen-Fishman stochastic growth model, which derives discretized length-specific growth probabilities that are both age and length-specific. So what you have here instead is a growth transition matrix specific to a particular age class. So all of the fish at length within that age class will then have their own individual length transition vector. And then that is plugged in. Kuan then developed this approach, which I really like, is you plug that then into the survivorship calculation in respect of length. So you integrate the effects of the growth transition matrix and the survivorship function in respect of length to give you the distributions of age at length in the following time step. The only downside of this, I expect, is that this may be even more computationally intensive because instead of one length transition matrix, you now have as many age classes as you've got in your model. Okay, so moving on to the next form of growth variability is intra-annual variability. There are many examples of growth being length-based and temperature-dependent. For example, here's one by Russell Miller on New Zealand snapper. We fitted a mixed effects model to some survey conditional age length data over time. And here you have the mean lengths at age. The numbers are the age classes and the lines are what join the age classes for individual cohorts. And broadly, you can see that in cooler years, the mean lengths at age were lower. And overall, he found that there could be a difference of up to 6 months of annual growth occurring, a difference of that amount, less or more, among cohorts, depending upon the temperature in any one year. So these effects can be quite significant. The age-structured platoon model does have the capability of including time variance in growth in respect of the proportions recruiting to each platoon, and in the individual growth parameters. So that can affect the temporal variability in the size composition among the platoons as they enter the population, and also the annual growth over all platoons within any time step. Just thinking about this, there could be a problem where if you have significantly slower growth in a subsequent time period, there may be problems of shrinkage, but I'm not aware of how that might be dealt with in this model. With the age size structured model, it can readily account for time variant growth simply by applying a temporal variation to the length transition matrix. And I noticed that in Gadget 4 of the 7 available growth options that are in the package do include a time-specific variable. For Kalen, what we did was to estimate a covariate in respect of the environmental sea surface temperature time series. And this was fitted to the time series of conditional age length keys, which were method specific. And it was found to significantly improve the model fit. So the covariates and the annual time factors, that was another option we used, was to, instead of fitting the covariate, you could actually estimate some annual factors, but they corresponded pretty closely in terms of their temporal pattern. And it produced predictions of weights at age over the time series of the model, which more closely matched the dots, which are the observed weights at age for particular methods, in this case, research trawl survey and the longline fisheries. So to illustrate the overall effects of these length-based processes in an age size structured model, this is just an interesting plot of the predictions of the Kalin mean weights at age for each year of the model period, where the colors are the individual age classes. And what this can allow you to do is to see the cumulative effects of the selective mortality in respect of length through time, individual, age-specific, and interannual growth variability, where these length-based processes are conserved within each cohort, and you can see the differences between the cohorts as troughs and crests in the distributions of the weights at age. Now, just moving on to spatial heterogeneity and growth, spatially stratified models can take account of this with region-specific growth rates that define the local size compositions within that region, but also have to deal with the fish migrating from other regions into that region. As Andre mentioned in his talk, the structured platoon model is rather ill-suited to describe this because growth is age-based. And so there's the problem of assigning a fish from a source region to a destination region that had a historical growth history, and now it needs to take on the growth of the destination region, and therefore there's the risk of perhaps shrinkage. There may be ways of matching those individuals in respect of their age to a destination platoon, but I'm not sure how one would deal with that. Rather, with size-structured and age-size-structured models, it naturally accommodates region-specific length transition matrices. And then to apply those to fish migrating into the destination region in respect of their length, they simply take on the length transition matrix or the region-specific growth rates of the destination region, depending upon the length of the fish when it migrates in. And so Gadget, I know, offers this implementation for temporal spatial variation and growth. In the context of the WCPO, spatial heterogeneity and size compositions has been well documented. Simon Hoyle and Simon Nicol presented a nice overview of the differences spatially in big eye tuna size compositions, and they attributed this to spatial variation and growth. It's been considered but not yet put into a production assessment in the WCPO. And thank Nina very much for these beautiful plots of the spatial temporal distribution of sea surface temperature in the WCPO, and it illustrates clearly the real degree of spatial variation through time of the warm pool and the cold tongue through the WCPO, which clearly spans the ranges of the region models, in this case, the big eye tuna population model. And we know that this is just an example for yellowfin tuna, the wide-ranging movement of tunas in the WCPO. So they will be moving from regions of warm to cooler temperatures, and so therefore encountering temperature effects which would influence their growth. And to properly account for the spatially stratified models would need to have a length-based growth function. So I would say that, to summarize, that temporal spatial variability and sea surface temperature in the WCPO really requires us to take account of these effects and modeling it to build that into the growth functions to reduce the misspecification in the stock assessment models. And at the most recent WCPFC commission meeting, there was strong support for considering the effects of future changes in sea surface temperatures due to climate change, and building that into the effects that will be modeled in stock assessments. And I think for developing a next generation population model, it really needs to be future-proofed for this circumstance. So to summarize then, it appears that age size structured models are not ideally suited to deal with all the sources of length-based growth variability. And rather the age size structured model would be, I think, the preferred option. that naturally has all of the length-based dynamics within the population model structure. And I would say that the existing sets of age size models do offer a really good template for developing a next generation model. And I think Gadget is 90% there with all of the T and B and R functions available for things like sparse matrix operations and OpenMP parallelization. It just requires some really clever programmers to help us strategically set up the structure of the code to be able to deal with the kind of calculations. And I think Andre made a really good point with regards choosing the length and age of your model so that you're not wasting a lot of processing time. So thanks very, very much for listening to me. And here's the set of references that I made in the talk. Thank you.
Okay, thanks, Nick. Anyone got any questions specifically for Nick's presentation? Okay, we have a question here. Mark Brevington.
Okay, can you hear that?
Yes, we can.
Yes, thanks,
Okay.
Mark.
Thank you. That was a fascinating set of talks this morning, actually. So I am quite glad I got up at 5:30 today. And I appreciate Nick's for bringing it back to tuna a bit and tropical tunas, because we're not trying here to deal with the entire universe of possible fish behaviors. But I have a sort of biological question at this point. We haven't heard a lot of mention of that. So my understanding, or what I remember, is that things like gadoids have been shown to have or believed to have quite big cohort effects on growth. So you get for instance, a massive cohort comes through one year, but they're all dwarfs and they stay dwarfy. Whereas what Nick is describing there, which sounded quite appealing, is a length is where it only depends sort of on length. Growth depends only on current length, but in a spatially varying way and potentially temporally varying as well. Is that right? Do we know enough to say that that's a reasonable description for tuna, or do we need to really worry about cohort effects? That kind of biological question. Thank you.
Yeah, thanks very much, Mark. That's a very good question. In that example that I presented, that was for New Zealand snapper. And we estimated both a temporal effect and an age-specific effect. So the age-specific effect did try to take account of the fact that if you did have young fish entering the population with a slow rate of growth, they tended to retain that for the remainder of their cohort time life history. So it's kind of like relating to the effect that you're mentioning there on gadoids, where if they start off as dwarfs, they're likely to remain dwarfs. And that's why you had that kind of time series of predicted weights at age, which is sustained through time. And that's possible with the age size structured model. Whether that's actually the case with tuna or not, I am really not sure. Probably if Simon Nicol or Simon Hoyle are online, they're more familiar with those characteristics. But I think suffice to say that with the age size structured model, you have the flexibility to include or exclude those effects.
So Nick, a related question to this is, if growth is just length-based and say selectivity and everything else is length-based and tagging kind of is data we have length-based, what benefit is there of including age in the model?
Okay, I'll give a big shout out to Mark, because a day or two ago he put up his hand and said that for close-kin microcapture, there is real, you really would need to have an age dimension in there for your time period, for that, the little I understand of microcaptures, you need to have that interval between your observations, and that relates to the age. Also, I think that age-specific growth effects are something which cannot be ignored. The difficulty with just a length-based model, as I mentioned, is that the length transition matrix in the size structured model applies to all ages within a length category. So you ignore all of the effect that Mark and I were talking about in respect of age-specific effects on growth. The other thing is that increasingly we are getting conditional age length data in for WCPO tuna. And if you don't have, for a size structured model, you cannot actively use conditional age length data.
Okay, thanks, Nick. Let's move on to the general discussion session. So any questions on any of the top presentations this morning, or just general questions or comments about size dynamics? Yes. There we go. Arnie, do you want to?
Yeah, I'm interested in the topic of the platoons that Rick Method covered. I'm wondering whether we see that as a sort of structure synthesis specific solution as they were never going to rewrite structure synthesis to be fully age and length specific. I had always perhaps seen it as a structure synthesis specific solution, but I think in the presentation and the discussion after that, it might be seen as an intermediate that is of interest to future software development as an intermediate in addressing the concept of the Rosalie effect, and perhaps many times faster than a fully explicit solution. Is that how the community sees it, as a viable recommendation for future software?
Yeah, well, I definitely see it as an intermediate solution. I mean, if you can get all the way to the age length, of course, do it. But you also are worrying about time varying growth from, any kind of environmental effects. That's a real phenomenon. Density dependent growth is a real phenomenon. There's a number of complexities that you want to be certain that whatever solution you pursue can play forward to not create a dead end for some other feature that you want to add. So I think you want to, and I don't know that we've been doing this. I don't know that we've been trying to map out all the potential avenues and how they would interact with each other before pursuing solutions of one sort. There are shortcomings of the platoon approach. It basically says that all the variation is effectively in L infinity, not in K, or not in birthday. Birthday you could add on, but it's just basically more platoons. Synthesis is very flexible in how many biological entities are in the population, in the total population at the same time. So birth date is one of them, platoons is one of them, and there are others that you could do. So again, I would just play it forward with all the other factors that you might want to add and try to avoid a bottleneck down the road.
Jimmy and Ellie, you got a comment?
Yeah, thanks. Really good talks, and Rick, I really appreciate that. I guess I won't say anything about Fisher Hatch, not born, but I do have a question about platoons and the role that they play relative to kind of management perspectives. So are they, I guess one question I have is, are the effective platoons, if they're estimated and diagnosed to be present, are they affecting management reference points similar? I'm thinking even proxies, spawners per recruit type calculation, how that plays out at different Fs. Presumably there's kind of an equilibrium type problem there. And I guess finally, I'd like to relate it back to yesterday's random effects. So you know, it seems to me that platoons are a way to fit data better, because there's evidence that they exist and we should try to estimate it. I guess the question is how does it propagate into kind of management, and how does using random effects affect the exchangeability, I guess, of how they could be used in assessments?
So Rick, do you want to answer that?
Yeah. I don't put forth platoons as a way to fit the data better. Hopefully it would, but it's a better approximation to how fish actually grow. And so it's a total alternative to a random effects way of thinking about the world. It's a mechanistic way of thinking about the world. It's just a better approximation. And in synthesis, it completely plays through all of the equilibrium calculations. Everything that happens in the time series calculations of synthesis happen in the equilibrium calculation. So yes, your MSY builds in the Rosalie phenomenon. And that's why we say it's a totally reversible effect. So you can get this playing all the way through.
Darcy, you have a question?
Yeah, I was wondering if Mark's question is related to all of this stuff before I ask mine. Mine's completely different.
Yeah, mine's kind of different as well, Darcy. So why don't you go ahead?
Okay, thank you. I guess, we've been talking about some very different models here, age-structured models, length-structured models, and then these beasts that try to mangle it all together in some way. And it seems to me like maybe we don't need to make a decision on which to choose. You could choose multiple different models. And we're lucky in that most of you guys have management procedures set up or go through the process of management procedure evaluation. So you could conceivably have a situation where you fit an age structured model and separately fit a length structured model, and then maybe in the future you try and get into full age length models or platoon models or whatever. But I think I can imagine a situation where you can have all of these things and fit to your various different data sets, and they might result in slightly different outcomes, but that doesn't matter if you choose an MP that passes all of your risk constraints or whatever, conditional on those different models. So I don't know, it's just something to keep in mind, I guess, is that you could conceivably have multiple different RTMB models, for example. Thanks.
Thanks, Darcy. Mark, do you have a?
Yeah, it's I'm trying to think and speak at the same time, so it's a bit of a challenge. But it's a bit. I'd say that there are some interesting tensions here because we've heard some extremely sophisticated formulations described, and yet from the tuna assessment scientists that I normally talk to, mostly they complain about the main data source being truly appalling CPUE, and all the sort of major problems that go with that. I think Rick's on the money in terms of not picking an approach that will unexpectedly then bottleneck us later on. But I'd like to ask a sort of higher level question in that context of some quite bad data and also some quite good data from tagging and potentially from close kin. So from a management point of view, we are actually trying to report on really large scale, estimate really large scale phenomena, numbers of fish in the sea, I think, rather than really fine scale things. And we have some sort of quite coarse data related to that. So I'm wondering, however, when it comes down to close kin, for example, because the only example I really can think about, what you have to do is be able to back predict something about the past size of an animal and its location, given where you caught it and how big it was and potentially how old it was. And you also need to be able to do forward projections in a similar fashion when you're thinking about half siblings. So that's quite detailed in terms of individual processes. And if I move somewhere else, I grow differently and so on and so forth. So you somehow need to be able to deal with that for those kinds of data. But to what extent do you need a full resolution of everything spatially fully for the much coarser data? There seems to me a bit of a tension here. And the talking thing's gone okay, but the thinking thing didn't go through so well there. So I'll just pause and see what people have to say.
Yeah, thanks, Mark. I think that to put that in context too is that a lot of our issues are because of fitting to length frequency data. And so a lot of this can cause some confounding with that, where the length frequency data is basically informing the absolute biomass abundances. And so we don't really want that. And that's if you have production aging, you don't have that problem because you've got the actual ages, right? So all of those length-based processes are really not that important. And even I don't do a lot of VPA type approaches, so I don't know how the weighted age is actually important in the final management decisions, but maybe there's some issues there. But again, if you have production aging, you have good information on weighted age. Our problem is that we have tagging, we have length frequency data, and so aging is not really that important. We're getting some aging now. There's still issues of whether it's good or not. But I won't get into that controversy. But also it's very expensive to collect and all that too, and we don't have historical data. So I'm not sure how important some of these things are in terms of age until maybe we get into the close kin stuff. But again, there's a whole lot of issues with close kin in terms of how the particular application works. So whether or not you can actually include all those necessary things for every application in a single model is another question. So there's quite a few things we need to think about. Anyone got any other comments on Mark? David, let me give you. There you go. Can you? We can't hear you, David.
Or now?
It's very low.
Hold on.
A bit better, yeah.
Microphone USB. Now? Can you hear me?
Great.
Yeah.
Very good.
Okay. Thank you. Yeah, I think, I'm rather convinced by some of the arguments of Mark regarding close kin, but I wonder one of the things that is a challenge for me is that we don't have historical data for most stocks coming from close kin experiments or a close kin design. So we're still going to rely on some information about stock productivity and fishing pressure from our traditional data sources. I don't know at which point you'll start. I don't know whether that's the case of Southern Bluefin, whether at some point you're going to, not rely so much on all these historical data sources, and therefore that you could rely on a simpler model to help you guide the management. I don't know whether we've had that discussion at all yet.
Mark?
Well, I much as I love close kin, I recognize that Tuna is going to be managed or mismanaged over the medium term based on traditional data. For SBT, I mean, there's always been this problem that we'll never know what the catch history really was because of all the problems associated with it. Close kin has helped narrow down some of those uncertainties, I think. I don't even know all the murky stuff there. Maybe that's but I guess some of the focus of this meeting is to try, exactly as Rich as Rick Mathot was saying, not to make a decision now about the work that will happen that will cause a massive bottleneck later on and cause it to all have to be undone. I mean, I take Darcy's point about you could consider doing several models, but it's a lot of work, right? So ideally, you don't want to mess that up now. I mean, close skin, I hope it's the future, but I don't think it's the present for all these stocks. I don't want to give that impression. You've got to deal with what you've got now. I do think the potential for epigenetic age is huge here. And I think that sort of even more this morning after hearing the talks, because the thing about it is that you don't need an otolith, right? You just need a jab from a fish. Now it will come with uncertainty, but it's an uncertainty measure that's independent of having to use length as a proxy for age in some sense. So that is a important thing to be planning for. But I suppose I'm sort of wondering about whether it's possible to have mechanisms in mind that would allow the kind of fine-scale individual reconstruction that you do need for, I think you need it for conventional tagging as well as for close kin, actually, in terms of place and age and size. You certainly do need it for close kin. And that's a different thing versus the kind of aggregate properties you need to be able to deal with removing numbers of fish at age from the sea. But I'm wittering. Sorry, so I'll stop.
Okay. Thanks, Mark. Jimmy and Ellie?
Yeah, just to answer David's question about SBT, the traditional data sources for the management procedure, they do include CPUE indices, and the concern there is, and I think it's already been raised, that for that fishery, the longline effort concentration has really changed from the historical period. There requires a lot of expansion into currently unfished areas, and that's part of the problem with the traditional data set for the management procedure. But yeah, the close kin is only part of the setting of the TAC, so the direct management of that. So it does rely on traditional data as well. But as the management procedure gets updated in the future, other types of programs like gene tagging is taking place, and so those things also play a role. So kind of recruitment side and spawning biomass are the two main data sources that go into the management procedure, but all of it's kind of conditioned on the operating model to test those procedures. Anyway, if Rich is on, he could probably elaborate.
Okay, any other comments or questions? Yeah.
Thanks, Mark. Yeah, I have a question about purely length-based transition in our, population dynamics models in general. So this is just kind of my personal lingering question whenever I think of this model. And do we really think, like fish, for example, like a fish in the same length bin with different age groups have same growth potential? Because like I often see that in pure length structure models, we only have a single size transition matrix, which means that the same fish in the same length bin should have the same growth potential for the next time step.
Anyone want to attempt to answer that question?
Well, I can attempt it.
Yeah.
I mean, we certainly know that there are differences between after maturation. So when fish are mature, their growth may change. So typically, I mean, in the models that we have attempted, we have tried to have different growth rates and therefore different growth length updates whenever you are for these two different stages. So so that in a sense is one way to deal with it, and but otherwise it sort of comes without saying, if the fish is sort of the same place in the development cycle, I would assume that and of a certain size, it would have the same opportunities to consume and grow. So it really depends on what other process do you think is going to affect the growth, and then you should try to model that in some way, shape or some way. Yeah.
Yeah, thanks. And it maybe the lobster model that Simon put together and Andre mentioned might be the way to go, where age-specific growth is more important for really small individuals, and length-specific growth may be more important for older individuals. Although you do have the issue of different individual variation in L-infinity, which kind of goes against that comment. Mark Brevington.
Yeah, just another to kind of cut down the dimension of things we're thinking about. For tuners, how many of these processes do you think really are fundamentally age-driven versus fundamentally length-driven? So maturity being a case in point. Do you think that for tuners, they are not maturing until they're, I don't know, 4.5 years old exactly for big eye, or because they hit 138 centimeters? Question over.
Okay, Nick, you want to answer that?
Yeah, good question, Mark. I can only speak in terms of what's been done in recent years for the tuna stock assessments. Probably about 5 years ago, we've shifted to using maturity in respect of length as an ogive rather than maturity in respect of age. So that is that's what's input to the model, and then with the estimation of the growth function internally within the model, that is then assigned to a maturity at age. So yeah, the biological input is in respect of length.
Yeah, that simplifies a few things, and it is also relevant to what Becky just said as well. It's a bit simpler perhaps for tuners then.
Okay, so we've got to the break period. So thanks everyone for your presentations and discussions on length-based dynamics. We're going to come back at, I guess, 1:10. Let me double check. No, 1 o'clock. And we're going to start talking about more general concepts about implementing a general model. So we'll see you everyone at 1 p.m. Okay, welcome back everybody. So the last session for the workshop is going to talk about different aspects of implementing the actual general model. And we've got 3 different presentations on different topics related to that. And then we'll have a overall discussion at the end as well. And so our first presentation is by Rick Mathot, talking about his experiences with general models over the past 40 years.
Thanks a lot, Mark and Arnie, and thanks especially for organizing this session and attracting a good crowd of people. I see 114 people listening in, so that's just great. And again, as you said, this is a different aspect of the meeting, and I'm definitely going to take that up. I'm not going to talk about a different model at all. I'm only going to talk about a place to build that different model. So I'm going to take this as lessons learned from 40 years of stock synthesis. I'm not going to give that talk. I gave it back at CAPAM 2019, but it has been 40 years. I mean, the first anchovy model was in development by this time in 1985. And it was the first report showing an assessment using it was in 1986. Yeah. I've been thinking about this for a while. It's been quite a ride. But now I'm going to be talking in transition from that into our new modeling system. So a goal of a process like what I think you're launching into is not just the best technical model. As important is a system for users to apply models and for developers to add, test, and document new features for those models. It's a complete package that you need if you're going to produce production assessments rather than treat each assessment as a one-off research project.
Hey, Rick, we lost your volume.
You did? Really?
Very, very
Yeah,
low.
it's very low.
Really?
Still is, yeah.
Is it still low? Still low?
Still low, yeah.
Huh. I didn't change anything.
Can other people hear Rick, or is it just us?
Can you hear me now? How's
Yeah.
it going?
Yep, that's good.
Is it good? Okay, okay. I thought that was only a problem with meat. Anyway, maybe it's my computer. Anyway, your goal is not just the best technical model. If you're looking to deliver an operational assessment process, you need to think about the process for a system for users to apply models and for developers to add, test, and document those features. The world is a really different place than it was when we really first started to put SS3 or SS0 out to the world back in, it was pretty much the mid 90s when somebody other than West Coast Groundfish started to look at it. When we met many of these same people in this meeting here today, we're there in New Zealand in 2019, and we said we were ready to move on from that old approach to building models. So our recent history is, starting from that workshop, and there were others before that. We had the Boston workshop, right, where a lot of us got together. It was an IC-sponsored meeting, but we've been thinking about how we work together as an assessment community to deliver our product. We've never really got there. We don't have an international organization that is our home, right? We talked about that a little bit at the CAPAM Rome meeting, but we didn't quite get there. We still aren't there. But nevertheless, we've been making steps and doing things to help move in that direction. So the 2019 report summarized what we saw as the basic needs for a model to replace the then extant, 25-year-old models. And that pretty much stands today. I mean, I think we should be looking back at that report, what we said at that time. I don't think anything has really changed. The technical stuff has grown. We certainly have seen some new things come in play, seen the growth of whole new dimensions, particularly from AI. And I continue to see more and more things looking to find opportunities to move in that direction. We're not there yet. We're still looking at a dynamical modeling system. The National Marine Fisheries Service came away from that CAPAM 2019 meeting and thought about, could we make this step? Could we launch a significant effort to create what we now call a fisheries integrated modeling system? It was a big deal because we were making a commitment to step out of the single developer kind of world and to actually put together a national team with representatives from each of our 6 science centers and a cadre of programmers largely in our national office, and have them work together collaboratively to do all the things that we said needed to be done back in 2019. Our FIMS model has now achieved that basic capability. It's already seeing some side-by-side work with existing assessments. And we'll see more of that happening in 2026. And it is slated for an external review in April of next year. So it is coming along. It's slower than we wanted it to be, for sure. It definitely doesn't have all the features that you or not could want. But as a modeling system, I think we've achieved what we set out to do and are continuing to build upon that. Now, let me go back a little bit and think about some of the factors that in hindsight, led to SS3's success. It was a large degree build it and they will come. Build it and everybody came. It wasn't deliberate. It wasn't a commitment by National Marine Fisheries Service at the time to build a general model that everybody could use and market it to the world.
Hey, Rick, your voice is cutting in and out.
Really? Well,
Yeah, we can't hear you.
Yeah.
It's very, very low.
Huh. Boy.
Just sit closer.
Logging. I don't know what to change here.
It's good now, yeah.
Is that better?
Yeah.
Okay. Okay, so what was it about SS3 that I think helped make it succeed? One was it was targeted on the data moderate world. It wasn't another statistical catch-and age model. It wasn't going after the same niche that SAM and other models have very well filled. It was able to integrate all aspects of reference points and projections into one total package, so the variance propagated all the way through. It had a lot of features, and they kept growing. Even though it was growing with features, it was backwardly compatible in I/O, except for a few transitions along the way. There was a big role of the early adopters to spread the word around. I mean, Mark, you were one of them for sure. Andre for sure, and several others. Carmen Fernandez took it to ICES. Mike Schriba helped take it to ICAT. I mean, there's a number of people who were instrumental along the way in getting us there. We did some trainings. The development of R4SS as a interface, both at the back end at first to produce reports, but increasingly on the front end to help people use it, was instrumental to things working. Being available as a help desk, being available to answer questions. If you're going to build a model and user community goes on it, you are going to need to deal with the basically help desk aspect of it. CAPAM itself was huge in helping to organize and move along the community of users of SS3. And the final component I'll put out here is that the fact that Andre used it so extensively in coursework at UW, it's basically introduced a whole generation of students to it. All of these things together really led to SS3 being used as broadly as it is. About half of the assessments in the US are based upon SS3 today. So it's been a big deal. But it's something that, it's time to rebuild it. And that's what we're working to do with FIMS. So, just reflecting on the general aspects of widespread use of any modeling platform, certainly you have a situation where bugs are less likely to escape notice. So many people are using it. You get the development of associated tools, all the R4SS kind of things. And you just...
Hey, Rick, you're cutting out again. It's very low. I'm not sure if you need to get closer to the microphone or something.
It's this atmospheric river we're drowning under. Do I have volume now?
Not very good, no.
It's a new problem.
It's good now.
Okay. So, the points are here at the bottom. Having a general model that many people are using, you just develop a common language around it. You get more advice on how to go about building your models. When you have a reviewer come in, they know what to expect. They're speaking the language. It's easier to understand each other's results. All of these are factors that are great benefits that you get by having commonality in our modeling platforms. So there are a lot of shortcomings that developed along the way too. It's a huge and convoluted code. I mean, it's probably pushing 40,000 lines of C++ now. And it's really feature rich, but it was never optimized for speed. It was always good enough for speed. It's an ADMB, and ADMB is, has come to development end itself. I'm a single developer on it. Some other people have contributed, but the major aspects of it are only coming from me. And I was really, really late to R, and I'm still not all the way there. So I couldn't really contribute on that side. So, having a team that builds in a expertise from different people is an important part of what a new model needs to be. The input for synthesis became increasingly convoluted over time. Our user manual helps, but it itself is convoluted and grew organically over time. We had a fascinating experiment that happened just a couple of days ago. Someone did a ChatGPT inquiry about synthesis and came up with remarkably insightful answers, I felt, about how to use it. And it was eye-opening that, you don't necessarily need to build the greatest user manual. You just need to make the information available so it can be gleaned and processed in that way. And thinking about that as something to use as we produce a next generation of models, I think is something that is very worth considering. Rather than build the glossy one manual, maybe it's just more about having access to a lot of answered questions that can then be gleaned by AI along the way. Synthesis is penalized Deves. It's not random effects. I don't think that it matters as much as many of you do. I think as long as you have the variance term about right, you're going to get the right answer. You may not get the exact variance right, but I don't think that's our biggest problem. It's not multi-species, but we do have cannibalism in there. We do have predator-prey capability, but it's not really a multi-species model. And it's spatial, but it's not highly spatial. So there's a lot of places where it really can't fill the needs moving forward, and it's not going to. So, again, thinking more about this, dealing with the IO aspects, I just totally bought into just using the ADMB approach of reading things one thing at a time. And so you already need to utilize that in the features going forward. So we built a separate GUI at one point in time, but it was really slow and we didn't quite get there. We had R4SS come along about the same time and built some IO routines that ended up working very well. And so that I see more and more people just interacting with SS3, not through the text file, but more through the R4SS approach. And then Jason Cope came and built the RStudio approach for it, or RStudio app called the Continuum tool, which basically presented a very slick interface for starting users to get involved without needing to look at that text file for synthesis at all. So there's been a lot of growth over time. Thinking again about the general aspects of where we need to go, it's a bit hard for a model to be an operational model, a research model, and a teaching model. Yet synthesis was active in all of those roles for a long time. It's hard to service a user community that doesn't have a high degree of expertise in building models. Their job is to apply models. It's hard to service them and to keep pleasing the power users who are largely the people we're talking to here today. When you have a high flexibility in model options, you need to temper it by guiding users towards good practices. Mark, with the CAPAM series, you've been striving for that for a while. You've published papers along those lines. And I realized that in being really open to providing options, the balance was not right. The pendulum swung too far towards providing options and not enough of guiding users towards a good practice. And more of that needs to be built into a next generation of models. And, finally, just, the general finding that, a single developer, yeah, it can work for a while, but it can't go on forever. And it's going to end up in some stagnation and gridlock. There's a long list of unattended to issues in our GitHub repository for the stock synthesis code. So there will be no more major features added to SS3, even though Andre, Rich, and company did add in CKMR to their fork of the code. We aren't going to be adding anything big to SS3. My own tenure with NOAA is winding down. I don't have a date yet, but it's a lot closer than it was. ADMB may be breaking with some future compiler. We already have a lot of challenges keeping the iOS aspect of SS3 operational for folks. Our major energy as the National Marine Fisheries Service has gone into supporting the FIMS model development. And a lot of the key SS3 and R4SS developers are part of our FIMS development team. There's a lot of synergy there. There's a lot of lessons learned transferring, as well as folks from other parts of our model development efforts are also involved. So, and we've also reached out to several other developers. The Castle 2 team, Gadget team, others are people we've been in contact with all along in the development of FIMS. The workflows and output processing aspects of FIMS is an important part of it. It's a modeling system. It's not a model per se. It's more than just a model. And all of that is building pretty strongly on our R4SS and other systems background. So we're now approaching a point where power users will be able to add a feature to a fork of FIMS code and, through the power of GitHub, keep everything organized and managed and see it built into other core code eventually after suitable testing. So, transitioning now to where are we at with this? There's a lot of information available online. We really invite you to come take a look. You can kick the tires. You can download an operating model. We are doing some onboarding, continuing to do development with major features that we still need to develop, but it's not about us developing all the major features. We want to invite everybody to get involved and to Okay. Are we back now? Is this good?
Yeah, that's good. We can hear you clearly.
Okay. Again, I'm not changing anything, so it's a mystery here. So we're now well along with being prepared to invite more people to be trying it out at the fundamental level that it's at, but also to be considering of how we can use this as a system within which models with the features we're looking for can be built. It certainly doesn't have all those features yet, but it's a place where all of those features can be built. We're again, doing the CIE review in the spring. We'll be having representatives from all of our scientific and statistical committees from the councils around the country engaged in that review. We're really looking to, expose this more broadly so that people can be doing comparisons with their projects and thinking about how we can use it. Given the audio problem, I'll cut it a little bit short here. Mark, you asked me to talk a little bit about the target features that you're looking for and where we stand. And I'll talk about, how close SS3 is to providing those so that you could be using it as an interim model for the problems that you have, as well as, what is it going to take to get FIMS in a position to be able to provide those sort of features. So with regard to spatial structure, SS3, has space and it has populations. And populations are things that are distributed across spatial cells. Spatial cells are places where activities happen. Space is a place in which all the animals in that space are experiencing uniform rates. So you have populations interacting with space. Some aspects aren't there in SS3. The spawner recruit is not regional, it is only global. And also, growth is by population unit. It's not by area. It could be, I have a vision for how it would be, but no more major features. With regard to tagging data, yes, we have tagging data, tag recapture, but we don't have hardly any tag recapture models for our domestic fisheries. So it's not something that has received nearly the attention that it needs for the tuna models. There are some things that could be done to get it to be, it would be easy to make recaptures conditional on the total recaptures as it is in some of the Rich McGarvey's work. But to really take into account the length of fish, length-based tags better than we do today, that would be a big deal. Again, random effects are there in ability to have time-varying processes, but the variance of those processes is not something that you can expect SS3 to be able to estimate for you. Close kin mark recapture, you heard it from Rich and his team. Length-based dynamics, we've been talking about that this morning. Yes, there's a good degree of development of length-based dynamics using the platoon approach in SS3. With FIMS, we have populations in there now. The area aspect is not yet fully developed, but that is certainly something that is out there in the development pathway. Things like adding in tagging data, again, if you as a user community need that feature, I see that is the kind of thing that, getting engagement from more of the power user community that's outside of our current FIMS team will help us get those kind of features in sooner. Random effects are in there now on parameters. That's something that can be worked. There's a manuscript in process. Close kin mark recapture, again, that's out there. It's not something that's an active development because we don't have any assessments that are currently relying upon CKMR. So it's not been a priority to put in first as that kind of a feature. And length-based dynamics, we're currently in the process. We already have the ability to look at length data, and the growth estimation is up next, and that whole line of development will continue to evolve over the relatively near future. So again, we offer FIMS as a modeling system, as a place where we can have consistent approaches, where we can have different flavors of models plugged in and out. We have already a separate pathway inside of FIMS to do a surplus production model. So it's breaking away from an age structured model, but in the same system, it can look at the same data set using a surplus production model rather than the age-structured model. So unlike synthesis, where if you wanted to do that, you basically do an age-structured production model with the responder recruit curve. You don't switch completely over to a production model concept. So this would provide a total production model concept. So the ability to plug and play is part of the concept of having a modeling system. So let me stop at that point, Mark, and see if there's any questions and see if I can keep my mic active to answer them.
Okay, thanks, Rick. Any questions for Rick? Don't have any questions. So, Rick, have you got any examples of where an outside person, outside the NIMS development team, has contributed something to FIMS?
We're essentially doing that right now internally. We just brought a brand new person into the team, someone who didn't have history with the development of it to date, and they're now charged with one aspect of the growth development. And so we recognize that the proof is in being able to do it, and so we're doing an internal test along those lines right now, and we will learn from that.
Anyone else got any questions? Oh yeah, we have some. Elizabeth.
Yeah, I just wanted to expand upon what Rick said in terms of outside people developing, and that FIMS does have what they call it a code club. And if you go to the FIMS website, there's a calendar that has it. It's once a month, it's a 3-hour block. Outsiders are very welcome to come in. And essentially, it's utilizing the concept of buddy coding to help people learn how to code and work on issues and features together. You can go and lurk and just see how it works. There is a lot of investment, I think, coming down the pipeline to build up an infrastructure to teach new users how to utilize FIMS. I have volunteered myself as like a dummy who doesn't know the first thing about coding in TMB or RTMB or C++ or any of the above, but is interested in learning how to do so. And the point of those code clubs is to make the barrier to entry to doing exactly that very low. So just wanted to plug that as well.
Thanks, Elizabeth. Any other comments? Okay, I think we can always discuss some of these topics later in the overall discussion, but let's move on to the next presentation, which is Darcy, and he's going to be talking about his experiences implementing models in RTMB. Okay, we can see your screen, Darcy. It's not in full screen yet. Yeah, that's good. We can't hear you though. Still can't hear you, Darcy. Can anyone else hear Darcy? So Darcy, we see your microphone open. We just can't hear you. You want to try and change your audio sessions. selections.
How about now? Is that working?
Yep, that's great.
Yep. Sorry about that. I had to disconnect and reconnect. Anyway, yeah, thank you guys. It's been great so far. So yeah, I just wanted to share some stuff, you know, some experiences, I guess, with using RTMB for a few stock assessments I've been doing over the last year or so. So I guess, you know, I've got 3 examples that I've been working on. We've got an age-structured model of southern bluefin tuna that I wrote up for CCSBT and RTMB. Initially, we'd coded that in TMB, but then decided that actually moving that to RTMB was sort of more useful, and I'll sort of talk to why some of that came about. And then this year, for the first time, I sort of recoded a length-based model that we have for New Zealand red rock lobster. So that used to be done in Stan, the modeling language Stan, and since ported that to RTMB and used it successfully for 2 assessments this year. And then currently working on a combined age and length structured model for, you know, that's still pretty early days, but yeah, I've been sort of working through the challenges of developing up the size transition matrices, and you know, whether I want that to be by age group or not, and all of that sort of stuff. So I guess, you know, from this list, you can kind of see that I'm probably a bit different to others in that I tend to make these kind of bespoke or tactical models that are very species specific. And I don't know, I guess that's just a personal preference of mine. I prefer to have much, you know, a lighter code base per model, and get things running a bit faster, because generally we're doing Bayesian inference, so I need to speed things along. So yeah, I'll carry on. I picked I guess a random suite of topics, things that I thought were interesting to talk about when using RTMB. For example, you know, RTMB itself comes with a bunch of density functions, or likelihoods, if you want to call them that. So, you know, the normal distribution and log normal and things like that. Or then there's another package that's available now in R called RTMB dist, and that adds a whole suite more densities that you might want to use. And then there's more to these density functions, so you can get into stuff like simulation and one-step ahead residuals. Then when developing the bluefin tuna model, we had some challenges there. So, you know, we have time-varying selectivity in that model, and we sort of thought that you know, initially we started with Gaussian Markov random fields as potentially the way forward there, but then found a few issues there and moved on to some 2-dimensional AR1 processes instead, and that seemed to work out for us. I talk a little bit about MCMC using Cole Monahan's sparse nuts package, which has been amazing to work with. And then I guess the last half of the presentation is just looking at sort of mainly documentation and unit testing, you know, sort of how to automate that, and you know, combine things like the test that package, Doxygen, package down, Corto, and GitHub all into one sort of suite of software that you'll use from start to finish. So looking at kind of the density functions and stuff, you know, as I said, you've got the common functions naturally in RTMB, but then you just get oodles, way more than you're ever going to need, I suspect, in RTMB dist. So you've got all the useful ones there that you can see, like the Dirichlet and Dirichlet multinomial and a whole bunch of other stuff. And so, you know, obviously, when you're writing up your RTMB code, it's pretty easy to call in these various packages and functions when you're writing your various functions for your stock assessment. And I touched on it. There's more than meets the eye with these density functions. You know, obviously they return the log density if that's what you want from them. But by simply declaring your observation, so say you've got some observed CPUE vector here, by simply declaring that as an observation using this little function here, you get access to a lot more. So all of a sudden you open up the ability to automatically simulate from the density that you're fitting to. And that in turn gives you automatic access to one step ahead residuals for whatever data set you're fitting. So, here's an example of me in a rock lobster stock assessment fitting to some CPUE time series by season and year for a variety of different data sets. And so we've got the data are sort of the red observation points, and then the kind of model's prediction in green. And then I think I just drew 10 different random draws, simulated data sets using this feature within RTMB. So, it might not sound like much, but that's pretty useful in terms of the the stock assessment workflow. It's really enabled us to pick up problems with stuff like data set weighting quite rapidly and things like that. And then on the OSA residuals, because you've got that simulation feature attached to these density functions, then the OSA residuals have all been built into that as well. So, it might just look like a denorm function to most people, but it's actually quite feature rich and really helps the workflow and speeding up things when doing various stock assessments. Then, one of the challenges we had when recoding the southern bluefin tuna model, so this used to all be done in 80 model builder, and we had sort of these selectivities that were set up by age and year for each of 6 different fisheries. And so in that old AD&B model, there were some penalties used to prevent sort of erratic shifts in selectivity by age, or encourage dome-shaped selectivity in some of the fisheries, or control how much selectivity could change through time. These selectivities, basically the penalties needed a fair bit of semi-subjective tuning, I guess. So sort of tuning the various parameters to make things look how we thought they should look. So one of the obvious first choices, I guess, when moving away from that into RTMB or TMB, was switching to Gaussian Markov random fields. So there's been a couple of papers written on this quite recently. In this example here, they were looking at not just age and year, but also cohort effects and selectivity for stock assessments. So we had to go at the Gaussian Markov random field stuff early on, but found there was some instabilities, I guess, during the estimation phase. So we just couldn't really get sensible estimates of the selectivity hyperparameters, stuff like the autocorrelations and standard deviations. When using any of the Gaussian Markov random field forms, generally the models wanted to assign everything to the year autocorrelation and do very little to age, and you had to do a lot of forcing and fixing and stuff like that. So of course you could fix some of these hyperparameters, and this generally worked okay at that point. And we could get models to fit using Laplace approximation or just MLE or whatever. But when running MCMC, we found that we were running into sort of further problems again. So we ended up with hundreds and hundreds of divergent transitions when running our MCMCs. So that this is kind of one of the diagnostics that arises from doing MCMC using Stan's NUTS engine. And we kind of noted that these issues didn't seem to be apparent when just using MLE or the Laplace approximation. They only sort of reared their head when getting into MCMC. However, after a while, we managed to figure out that there are other formulations that we can use, and so we moved to this 2-dimensional AR1 prior for time varying selectivity. And lo and behold, all the MCMC diagnostics improved. So, this is just, I guess, one example for one particular stock assessment. So I'm sure this will change on a species by species basis or whatever. But yeah, I just thought it was an interesting example to work through. So here's the sort of code to do it on the left-hand side here. It's incredibly concise. You've basically just got your, your auto-regressive functions for year and age, and then you combine them in this way within RTMB. And then on the right-hand side here is one of the examples of time-varying selectivity for the Indonesian fishery for that SBT. stock assessment model. And yeah, so basically now we've managed to get this model with, we've still got our 6 fisheries and 2D AR1 processes operating for most of them. We've got this other sort of minor fishery there where we just sort of cohort slice and direct remove that fishery because it was sort of back in the early days and very little catches. But otherwise, it all seems to be working well. Something else that's near and dear to my heart is being able to do MCMC for these stock assessment models to help us represent parameter uncertainty and then use that within projections and so on. So Cole Monahan has put in a heck of a lot of work into this R package sparse nuts. So it implements the nuts algorithm. And he spent a lot of time working out how to decorrelate and descale the posterior distribution before passing all of this stuff to Stan. So all of this happens in the back end, and it's kind of wrapped up in this really nice sample nuts package now. And it can kind of automatically deal with that decorrelating, rescaling for you. So basically what it means is that you can fit your model initially, and that might just be an MLE or using the Laplace approximation. And then when you use the sample S-nuts function, you automatically, basically that automatically generates the mass matrix, which is required to deal with all of your jump sizes within the MCMC, which speeds things up a heck of a lot. So, in lobster, we had models that were taking sort of days when we did it back in ADMB, and then sort of tens of hours using Stan, and now we can get MCMCs fully mixed and back ready to use within 10, 15 minutes sometimes. And that's been our experience with the simpler age structured model, and for SBT as well. It's just really sped that whole process up for us, which is pretty handy in terms of workflow. And then, I guess just showing that this seems to work well for all of the various MCMC metrics as well. So here, we've got the fuzzy caterpillars, the MCMC trace plots, and plots just showing that the effective sample sizes and R-hats are pretty good when using this feature. So thanks to Cole for all of that. Now kind of moving away from the technical stuff within inside the model, moving to kind of documentation. So I found it really useful to use this package called teststat. So basically within, using teststat, that you can make up little unit tests for your stock assessment that's wrapped up in an R package. So you could compare to two different functions, or code up an expected value of something, and just sort of set that code within your GitHub repository. And then whenever you do some work on a model, it just runs your unit test code and sends you an email if something's not working. Or you can use this test button in RStudio or at the command line. So that's pretty helpful for sort of rapid development of your model as you're going. You can just sort of do a bit of work, push it up, and then bang, you get the tests done and get some results back pretty quickly. I'm sure a lot of people are using this sort of stuff already, but I don't know, maybe not. Documenting the R package. So, it was when doing the CCSBT model, it was really important for us to ensure that we had really clear communication and documentation for that code. Basically, we wanted to bring along all the member countries with us and help them better participate in running the stock assessment models into the future, rather than just a couple of countries sort of doing most of that stock assessment work. So, there are a few different ways you can do this. The way I've sort of gone with here, so for each function that you write in RTMB, you put in this little Doxygen header, and that's obviously going to do a lot of importing of packages for you and write up some help files for those particular functions. And then you can use your R packages vignettes. And in this, you're sort of, rather than just documenting the functions itself, you're starting to document the wider R package, which can be useful to show examples of how to work through various bits and pieces. and then automate the entire workflow. So, the package down and the vignettes with using package down. So now you can set up a workflow within GitHub, which will automatically, run your unit tests and then build your package as well. But then also rebuild all of the documentation and launch that online as a website for you. So all of a sudden you've got this automatic documentation thing going on, and you can go and look at the website for help functions and at the vignettes, and other people can get into that easily. So just some sort of examples of some of that automated documentation. You've got a sort of a landing page which shows you how to install the package, and any other packages that you need to get into first, and then getting started. So how to run a basic stock assessment, and then there's various articles for looking at the more specific stuff like how to do an MCMC or some of the equations themselves. And then under references, you've just got all of the functions that make up that R package, and then the help files associated with each of those functions. And yeah, you can basically set this up pretty easily, pretty rapidly for a variety of for whatever R package you've developed. And then I guess the final step in the workflow that myself and my team have been using is, you've got the R package, which is the stock assessment code, but then the model itself, but then you want to document each of your individual stock assessments. So to do this, I've found using Quarto has been extremely useful. So R Markdown used to be a really good choice, I think, but Quarto seems to be a lot better. It's sort of fixed up a lot of the really annoying issues that R Markdown had. So much better at generating Microsoft Word documents, way better at cross-referencing figures and tables and all of that sort of stuff. And there are a variety of other neat tricks as well, like you can turn everything into an HTML or a Word document or a presentation, which has been useful. And then there's some features in there for sort of graphics that can move or pop-ups and stuff like that, which is kind of handy at times too. And we've found that these websites associated with the individual stock assessments or individual model runs have really helped us include our stakeholders and people that are interested in this stuff, and it's sort of proven extremely popular over the last year. So this is all kind of pretty easy these days now that Quarto has been well set up, and then it's all very well supported at the other end on GitHub. So it'll automatically, again, you can set it up to automatically build the website and launch it for you, and then you don't have to do anything there, which is nice. So just in time, I think. RTMB, I think everyone understands it's a pretty powerful tool for stock assessment modeling. But for me, I guess one of the most powerful things has been the workflow and semi-automation of a lot of these features. So the really useful stuff with those density functions, a lot of people doing work on the Gaussian Markov random fields, and the nice tidy functions that Casper's worked up for say doing the autoregressive functionality, all the Cole's work on sparse nuts, and then just in general, all of this means that development and testing has become extremely fast. If someone asks for a feature during a stock assessment, it's pretty quick just to add a function in there and inject that into the main part of the code. And it's also helped us with sort of beyond the stock assessment. You can recycle the exact same functions when doing projections or management strategy evaluation, or just wanting to test, say, a chunk of code like the growth transition matrix within the model. And then, the documentation side of things, I think, has really improved quite rapidly over the past few years with all of these various super helpful packages. So that's it from me. Thank you.
Okay, thanks, Darcy. Anyone got any questions for Darcy on his presentation? Mark.
Yeah, thank you. That was extremely impressive. I like it. I share a couple of your feelings. I think that the making it case specific is actually very helpful. And I really like the concise nature of the code. That really helps, I think, keeping things tractable. I have one technical, I suppose also that you're leveraging all this development in the wider statistical and I don't know, data science community. That's really powerful. I just have one sort of technical question. What do you feel you've really gained a lot by MCMC versus just going with Laplace approximation? That's really my question for you. Over.
Yep. Thank you very much for all of the kind words. And that's sort of something that's really been a priority for me, is leveraging other people's hard work. I think that's been extremely useful. In terms of MCMC, I guess here in New Zealand, we're kind of required to do it to some extent. So that's always been part of the puzzle there. I guess it wasn't really required for the Southern Bluefin tuna model. We always had this kind of grid of, MLEs or Laplace approximation, whatever you want to use there. But I guess in our early explorations of that particular model, we've actually found that the parameter uncertainty has been quite high. So we were, once we first did an MCMC and realized that, we were pretty excited to include that as part of the grid as well. So now we're just going to have a grid of MCMCs, and it'll be a slightly smaller grid. So, useful for, I guess, injecting more uncertainty into our projections and management strategy evaluation. I guess the other thing that I've also found when doing MCMC is that it flags issues that don't seem to raise their head when just doing MLE or the Laplace approximation. Stuff like there are some underlying issues, I guess, with some of these selectivity setups, I guess, in some scenarios. And I think it's just enabled us to better access and better understand some of those problems.
Jimmy and Ellie.
Yeah, thanks for the question too, Mark, because just on the one thing that Darcy just touched on was the importance that the conversion was for the operating model and conditioning, which is like conditioning the assessment, but it is, and the Laplace approximation is less handy for testing management procedures. So it's a lot easier to do it off of individual draws from MCMCs. And that's a huge point and change in the way SPT has been done. Prior to this, the 80 model builder MCMCs were really long and difficult, and they had issues just being able to do it. And so all of the uncertainty was captured through structural grids, which now we think didn't really capture as much uncertainty as we're getting now, is what Darcy just said. Thanks.
Dan, Lando, I guess.
Yeah. Yeah, thanks, Darcy. That's really, really interesting. I'll just, before I get to me, I'll just do my random also support for MCMC, kind of building off Jim's comment. On top of the MSE thing, the part that I always find much more appealing is it's much easier to kind of calculate uncertainty around kind of weirder derived properties, right? If you wanted to know what's the uncertainty in the slope of the abundance of female age 2 individuals or something like that, right? That's a trivial, calculation from an MCMC output, whereas, I'm sure a clever person than me could do with the Laplace stuff, but trickier. I think this is more of the dreaded comment than a question. I think it's interesting, as we think about software development side of all this, right? That on top of kind of the development of the models themselves, right? We're now also kind of looking at reliance on developers that are actually developing the statistical tools themselves, right? The languages to an extent, right? RTMB and now sparse nuts and all this stuff, which is fantastic. I mean, again, just incredible work there. But I suppose it is a brittle point in all this, right? In that, I don't know how many developers are working on sparse nuts besides Cole, as opposed to like the entire, team at say Stan or something like that. I'm not trying to say one or the other. Just it's an interesting point as we think about the future of these things, is like, how do we maintain kind of the funding and support and work for kind of if we're not only writing the models, but kind of the languages underpinning the models, that's a lot of work on the community that need support.
Thanks, Dan. I want to bring up a point about the workflow and everything. Yeah, I'm not that familiar with all this, but Darcy, it seemed as though the stuff you're presenting is quite useful for a single developer. But what about collaborations? I mean, are all the tools you're talking about here facilitate collaboration as well?
Yeah, I mean, I definitely think so. Working on GitHub, you can have different people working around the globe on different parts of the model simultaneously, and that's all well and good. And if any one of you say pushes a code change, then it runs all of your unit tests and rebuilds all of the documentation for you, and you'll be flagged. You'll get flags if something's gone wrong along the way. So yeah, I mean, I don't see any problem there. And then the R package itself is made up of you might have a main function body that declares the stock assessment model itself, and then a whole bunch of other functions that do different things. So there's no reason why people couldn't be working on one part of it separately, just looking at the growth on its own, making sure all of those functions are doing what they should, and then bring that into the model and introduce it. So yeah, I mean, I've worked with, there's about 5 or 6 of us working on the rock lobster stock assessment, and then we've had a lot of to and froing and SBT, and people like Jimmy and Ali and Anna Palmer and Rich Hillary and Paige. We've all been working on it simultaneously. So yep, I think that lends itself well. Thanks.
Elizabeth, you have a question or a comment?
Yeah, I have a comment and 2 questions. I agree that documentation is so important, and even good documentation is super important, because like AI can only understand so much. And yes, we had a user with SS3 that was able to ask a question and get a really good answer, but I've also asked questions and gotten really bad answers because like the documentation says one thing and then it says another thing. I also think documenting a lot of the doxygen, roxygen, package down, all of that is very easy, which is wonderful these days. However, creating vignettes that can bring a really new user that doesn't know anything about this to being proficient in it is actually rather difficult to do. And AI helps you a little bit, but being able to create something that really teaches users how to use what you've created is somewhat of an art form. And then I have 2 questions. One is, do you have many people forking your repository and contributing to it? And then the second question is, when you do have people request new features, are you testing them out? Not like test that, but like trying to test whether or not it is a feature that is worth putting in and is yeah, up to date with the science and everything else.
Yeah, thank you. I guess on the first question, we haven't really had many people forking, say, the SBT repository yet, because that's still private at this stage. I'm still trying to figure out how to, I guess I'm going to have to separate the data from the model. I've kind of gone a bit too far there and integrated some of the data sets within the model framework itself. And that's caused some issues in that we can't share some of that data. So I guess that's another thing that's worth considering, as well as, putting too much documentation and examples within these models can lead to some of those issues. So something to think about there. And then, yeah, I haven't really had anyone interested in the rock lobster model per se. It's very specific to New Zealand rock lobster stocks, I guess, and we use it for 7 or 8 different rock lobster stocks here in NZ, but yeah, it's quite tailored to that fishery. So I don't think we've had a heap of people interested in that yet. And then as far as, injecting new features and trying to evaluate if that stuff works or not, I guess it's all sort of done on a case-by-case basis. And then, generally when you do that, it will break your unit tests and you have to go back and rethink about the unit tests and stuff like that. But that's kind of part of the process, I guess, part of the workflow that we've gotten used to. Hope that answers those questions.
Yeah, I just it seems like you're investing in this open science principle, and something that I just think a lot about is how like we get people to engage with these things that we're creating so that it is truly open science and you do have active contributors so that it isn't just a single developer. It turns into like a community of developers and contributors and such.
Yep. Yeah, I guess my experience is it's been pretty small teams working on this stuff so far, but maybe that'll change going forward. Yeah.
Okay, thanks. We got two questions there, Eric and Kian. Just wanted to make sure that the questions are about the workflow and development. If it's specific about details of stock assessment modeling, then we'll leave it till later.
My question was pretty much just answered. I was just kind of curious why it was still a private repository up there. And but I guess that does invite kind of a broader question of, if you do want to get a lot of stuff out there, are there ways of de-identifying and anonymizing sensitive data so that you could actually have a vignette or something that I'm not as familiar with? I mean, I've dealt with some sort of issues with confidential data and sturgeon and that kind of stuff, but
yeah, I think that's probably the best way forward for us, is just to scramble the data, I guess, and so then you still get a bunch of examples in your vignettes online and on the website, but they're not really breaking any confidentiality. But yeah, unfortunately with SPT we need to sort of put everything through the commission and get everything signed off before I can push it all online. So yeah.
And then do the GitHub pages get served up to the public even though the repository is
yes
private?
You can you can set it up to do that. So yeah, nice. Either way works. Yep.
Okay, Kian, do you have a quick question?
Thank you, Darcy. It was very good to see that you used all the good tools. And yeah, my question is, like, have you considered like including some kind of containerized environment in there? Like, I see that you have some unit testing, etc. But I think it's good to keep some kind of consistent environment. So that's my question.
Yeah, I saw you talking about Dockers the other day. I mean, I guess I've considered it, but I just haven't really built it into my workflow as such. My thinking at this stage is that we do enough sort of testing to not need that at this stage. But I guess I've never been bitten before either, so maybe that'll happen at some point.
Okay, thanks. Let's move on to the next presentation. And so essentially the final presentation for the workshop is Arnie. He's going to talk about several different components of the development that we need to consider when developing the next generation model.
You guys are talking, we can't hear you.
Yes. Thanks for that, Jim. Our presentation is not as profound or dramatic as Mark's introduction of it. Just skimming on some of the topics that have already been covered in the previous two presentations. Let me also note that Mark is the first author, and that is correct. He just handed me these slides, and I'm happy to serve his board. And I'll throw in a few Ernie comments, of course, as I talk over the slides. So this is the background of the CAPAM 2019. Many of you remember and probably cite sort of Punt et al. 2020, the published paper. But this New Zealand Fishers Assessment Report goes more into the sort of practical and technical side of how to run a software project. And that is what we're talking about here. So some of the initial decisions that we have been grappling with is, do we collaborate with existing development, such as FIMS, taking advantage of existing development? There are a larger team of experts and developers out there, and could we perhaps contribute Tuna-specific components to existing projects? Or do we create a Tuna-focused general model that will be, much lighter, and also will have more control over the approach, as opposed to be a member of a bigger board or something like that? It'll probably allow faster development and choice of programming language. One could also consider extending some of the fine-scale spatiotemporal models that were covered earlier in this CAPAM workshop, Sepodime and ADMove, where you have that, there are existing platforms that already deal with the spatial issues that are important in Tuna assessments. Another thing is about how are we going to organize the leadership and governance structure. There are some major organizational decisions that are in the next slide. Some important decisions about the architecture requirements that we're discussing today, and which main sort of software components will have to be there, selectivity, growth, and so forth. And as I mentioned in my introduction the first day, as the next step after this CAPAM workshop is that we're going to produce a specification document to guide the software development for the next stage. We will need to decide whether we have a pretty small and focused governance group. We'll need to decide who will be members, of course, in it. SPC and IATTC are pretty much given at this stage, some representation from them. Domain experts would be, of course, very useful. But if you keep it small and focused, it will keep things easier, won't it? Minimizing coordination sort of overhead, I guess, and make it efficient in that sense. But it is also, at the same time, important to consider a more inclusive governance structure that would include, of course, all the other Tuna RFMOs, some of the stakeholders, non-Tuna agencies, and again, domain experts will be valuable there. We touched on this a bit earlier today, that most software that we use sort of started off with a single programmer. That's maximizing efficiency probably in terms of coordination and consistency and consistent approach and so on. But often as software matures, we end up with a team and in the end a larger community contributing to software projects. And some things along those notes are going to be important for how we will proceed with the Tuna assessment software. Most of this was covered very well in the last presentations. The importance of collaboration, testing, continuous integration, version control, how to distribute the software, how to make things open source as much as we can, and documentation and automation of all of the above. So looking at code requirements, architecture to allow flexibility in additions, modular code to allow contribution. I think Darcy mentioned this, that you can have a stock assessment sort of R. Yeah, there's a top level R function that sort of calls all the other functions, and that is the way to make things modular. You can also have a somewhat small package, perhaps calling other packages. This is also about modularity. Efficient scaling is going to be very important. And the user interface, we saw some insightful sort of glimpses of code really today, how we can, both from Gadget and from Darcy, how we can sort of specify a model and pass data to it and do that through an R function interface. Generalized partitions, parallel processing. I think parallel processing is going to be super important. We are increasingly able to use a very large number of cores. So any new software development should be able to, and we also know that within these models, there are many, many processes that can be parallelized. This was a massive sort of issue with AD Model Builder, where Mark Wander and I and others were hoping that things could be parallelized more inside AD Model Builder back in the day, but a lot of that has been basically successfully completed in TMB and RTMB. There's a lot of automated parallelization, and also fairly easy to manually specify which calculations you want to parallelize. So that will be super important, I think, for the next Tuna assessment software. Also, the ability to simulate. Some of that comes kind of for free. There's a function called simulate in TMB and RTMB, but when I talk to some of the people that are into management strategy evaluation, they may need a more flexible and sort of purpose-designed software for that. So it's not a given whether the assessment software itself will have all the simulation capability for MSE, for example, but certainly the ability to sort of self-test, I guess. I think Mark should talk over this one. This is a diagram that he knows.
Okay, yeah, so this is just the diagram from a paper I published a year or so ago in ecological modeling. But it outlines sort of the whole process of going from the conceptual model through to management advice and all the different components. And you can see there that the general model is that reddy orange part in the middle, which is really just one component of the whole ecosystem of creating a stock assessment model. I also added in some new components there that were really important for the general model, such as the user interface and the output of reports and figures and things, and then added MSE in there, which is currently an important part of providing the management advice. So it's just outlining that the general model itself is only one component. We have to build all these other things around it to actually get the whole thing going properly. So it's a much bigger project than just coding the model.
Yeah, exactly. And that was a point that Rick also made very well. That, yeah, the software, sort of the core software itself is really just one part of a much bigger picture, community and that. There's an interesting point, sort of who is going to write the software and how. There is basically, you can see examples of stock assessment software where the code was largely written by, let's say, a computer scientist with little or no domain expertise in fishery stock assessment, someone who has coded a lot of other large projects and follows industry standards, really knows most efficient and up-to-date tools to do all of this, efficiency, and is just a master programmer. from as a core discipline. But we also see many stock assessment software that have been written by stock assessment scientists. There are benefits, of course, from having the domain knowledge of how these models work. And since we've basically chosen RTMB as the programming language, there are certainly more stock assessment scientists that are experts in RTMB than there are, let's say, computer scientists. There might be very, very few around. Another thing to note is that the resulting code often looks quite different. What we know as professional programmer industry standards, it just reads differently. There are often more smaller functions that are even producing other functions and so on. It reads different. So often, or perhaps, scientific a code written by a stock assessment scientist is often readable to other stock assessment scientists because of the kind of code we read and write. But there are great benefits also from professional programmer. I think of Gadget and Casal. These are the code is probably better organized than when a stock assessment scientist has written them. And so again, if it's readable and in the sort of style that stock assessment scientists write, it also makes them perhaps more able to contribute to that code base. For TMB, you're basically writing the models in C++, such as Gadget 3, for example. But for RTMB, you're basically just writing your the entire code base in R. So that's an important distinction there. And I think that's it. But it's almost there. So what components should we include in the software, let's say in version 1? We could try to narrow it down to very few user options, just decide what we consider good practices in Tuna assessments. Maybe we could look at what features are currently used in Tuna assessments, let's say around the world, so Atlantic, Indian, and Pacific Oceans. Or what we're probably not going to do is just include everything that we can think of. Pretty short and quick. We just wanted to sort of throw up all these, or throw in the air all these topics to have, to guide us into the discussion of where we might go from here.
Thanks, Arnie. So does anyone want to start with any questions or comments on the different components of producing an assessment model? Darcy.
Yep, I guess I'll go ahead first. I guess, RTMB seems like an obvious choice to me, given the just the additional automation that comes with it, really. And I think I just find it generally faster in terms of rapid development and new functionality and all of that sort of stuff. Just being able to write the code and then run it line by line it means a lot. It does to me anyway. So I don't know. That seems like an obvious first choice out of that set of questions.
Thanks, Darcy. Andrea?
I think another thing worth considering not only is who's going to write this code, but who is going to maintain this code. And that might steer you in certain directions because, say you hire a programmer to initially write the code, but then, 5 years down the road, you need to continue maintenance. How do you keep that up? And that's just worth thinking about.
Very good point.
Yeah, good point. David?
Yeah, I was going to make a very similar point that last time. I think the lesson with SS is that it took decades to get to a product. And I don't know what agency would have the ability to keep a dedicated programmer for so long to basically go hand in hand with the development of ideas of the scientific community. So I think it'll be challenging to do that.
Thanks, David. Elizabeth?
Yeah, I think another question is that, and this was mentioned before by other people, is that this isn't just coding the model, the infrastructure that you need to create vignettes, training, documentation, a community of users, teaching people how to do to use the model, teaching people how to contribute to the model and everything. That takes honestly just as much effort, if not more, than actually writing the model. And so I think a question that I have for y'all is like, if, and you don't need to answer this, this is just a question to think about, is if y'all want to spend the time and effort to build that infrastructure, or if you want to hop on to a project where people are already building that infrastructure and you can just create your own Tuna fork and rapidly develop there and then slowly contribute to that bigger project. Where people, like, that is such a huge job of the people developing that model, i.e. FIMS.
Yeah, that raises a really important and good discussion point. I'm curious to know, for example, whether and to what extent FIMS might move from TMB to RTMB. It's very understandable if they will not. They're, for example, Gadget 3, I don't see any compelling reason for them to move from TMB. They've already implemented TMB, everything they needed, and there's no compelling reason for them to move to RTMB. Darcy had a smaller code base to work with and found it beneficial to move it from TMB to RTMB. Stock synthesis, an excellent example of something that's just an ADMB, and there's not a compelling reason to move it to the platforms. But the reason I ask whether FIMS might move increasingly towards RTMB is because one of the main differences between TMB and RTMB, the main differences actually address very much, I think, the goals of FIMS. It's easier to make things modular, to sort of link together things. I was trying that out recently, comparing TMB and RTMB in that context, and also for user contributions and other things. I realize it would be a difficult choice to make, but I'm interested in where FIMS sees that.
Andrea, do you want to answer that question?
Oh, yeah. So we currently are continuing our plan of developing the major part of the code base in C++. This leaves us, it sort of, I guess you could consider it part of our forward-thinking plan in the event if TMB ever sunsets. We have code that's written in a language that is going to persist. I think the other thing to mention is that we're kind of structuring this modeling system, which is a fairly large code base in terms of lines of code. And we're not entirely sure at what point do you lose computational gains with RTMB, like with respect to the size of the model. So I don't know if that has been how much RTMB has been pushed with respect to lines of code, and how much can be actually efficiently computed. We currently our sort of hybrid approach right now is we have methods of exposing FIMS functions to RTMB, so that people could potentially take pieces of FIMS and build their own RTMB model.
Yeah, exactly. I attended that technical online workshop. That was really useful. Not, I think, specifically addressing how we might go about with the Tuna model, but it was an interesting demonstration. I guess just coming from the scoping project that I've been leading for the last couple of years, I would say we are very interested in collaborating with FIMS, and I think there would be mutual benefits on both sides. But the point being that we are definitely going to be in the next few months producing some code in RTMB, and it cannot. It's a shame how TMB and RTMB, even if they are from the same author and share the same sort of computational engine, that they are not super compatible for sort of linking and sharing code and things like that. So yeah, exactly. I think the way I see it moving, at least in the short term, is that we will continue and increase collaboration with FIMS, but it seems like the software will be separate, I would say. But if future FIMS products might be RTMB based, then the game changes very quickly, and we can start sharing functions and packages. So yeah, the will is definitely there, but the technical hurdle between TMB and RTMB is of relevance. Just about the possibility of TMB sunsetting, I just want to emphasize that RTMB is a user layer on top of TMB. And so even though the authors, so Kasper Christensen, Anders Nielsen, Kasper Berg, and all of their DTU team has moved basically to all the modeling of new, all the new model projects are based on RTMB. They guarantee the full maintenance of TMB because that is the computational engine that RTMB sits on top of.
Thanks, Arnie. Jimmy and Ali have a question.
Yeah, just a comment. Thanks for that last comment, Arnie. It's great to hear. I didn't actually know about that, but I don't know if this is the place, but to me, the future good practices has to make it fun for a broad range of skill sets. In my view, I think in the next year, people will be using AI to prompt stock assessments, unless we go completely carbon neutral somehow. That's a foregone conclusion that you don't have to remember how to do many things. You have to know what to prompt and how to change things that way. But it's not. I've been using a Codex kind of agentic stuff, and the amount that you can do that I could do by hand, maybe if I got all my ducks in a row and remembered arguments, but it obviously already knows how to do most things. So just wanted to comment that if we're stuck in our last 10 years of thinking, and things obviously are changing extremely fast, and the way we will work in the near future is also going to change, I think. That's my personal opinion. But on the good practices, I don't know. One thing maybe on the list is to have options for diagnostic development. That's kind of meaning like make the output so anybody can read it and analyze it and present it in the way they feel that's most appropriate. So that puts some of the fun into stock assessments, in my opinion. And I really liked your figure on the flow chart, iterating between those diagnostics, and I could easily see, I don't know if that's a chat GPT icon in the middle there, but yeah, it's like you tell it to, okay, well, drop that assumption and try this one, and it does it for you. And that's literally the way I think it's going to go in the very near future, rather than having to think too much about it. But I guess I would emphasize that you don't have to leave it. I'm not saying don't build backend packages that have like R4SS type figures, but provide some flexibility that the end user can also interrogate the output in a general way. And I think FIMS has done a really good job for both the input side and what I've seen of the output side of having it be very flexible to the users. Thanks.
Yeah, so this is actually an expert system from the 90s, which is way better than current AI. Unfortunately, we didn't have the data or the machine learning tools back then to actually do anything decent. That's right. David. David, are you there? You have a question?
Was that me?
Yeah.
Okay, thank you. Now, I was going to comment on the question on whether you should keep this IATTC and SPC or include some of the other RFMOs. And this clearly is my own personal opinion about ICAT. As you know, ICAT does not have a lot of capacity at the Secretariat in the technical aspects. And it is my feeling that they feel, the scientific community feels very much stretched with the current emphasis on increasing the number of stocks that are managed through harvest control rules and MSC. That I think it's very little chance you would have an institutional commitment from the SCRS to participate in the development. Certainly in terms of being users of whatever is being developed, but I don't think that the SCRS has necessarily the capacity as a committee to get involved in the development. There may be individual scientists within the SCRS, obviously, that would be interested in staying abreast of developments. My only suggestion would be that this is something that could also clearly be a point of discussion at the next methods working group of the SCRS, and whether there is any appeal for being involved in the development. Thank you.
Elizabeth?
Yeah, I think a point that somebody else made is some of the diagnostic stuff and the outputs, and whether or not y'all utilize FIMS or build off of it in some way. Again, there are already projects to work on those types of things, and automation specifically of outputs is something there's a lot of investment in, that is with the goal of it being model agnostic. I mean, they have it for stock synthesis, working with FEMS. And so I think also trying to, if you're not getting in, like building off of FEMS, at least trying to build off of those existing efforts, just so that y'all aren't having to reinvent the wheel, but contributing to these existing efforts, so that we don't have like 5,000 different packages that all do same but different things. And another thing with, I think, the idea that FIMS is built off of TMB is that, like, if a better version of a model builder comes along that's built off of C++, it could quickly switch to that instead of TMB. And I think, again, with this open source idea, is that somebody could, and with FIMS still being fairly early in the development, somebody could make a fork of FIMS that is like RTMB FIMS, that it takes it and puts it into RTMB, so that y'all could use it in your Tuna, and like whatever Tuna model y'all build. Yeah, sorry, this is just my soapbox that everybody's reinventing wheels, and I just am like, there's so much existing good science and code base out there. And I'd love to see more contribution to open source projects than just everybody having different repositories and packages that are technically open source, but you don't have like tons of active contributors.
Exactly. I think there's great potential in utilizing some of the BIM's infrastructure and tools. We're happy to discuss that and we'll benefit from it. Thank you.
Yeah. Okay, so we're going to move on to the discussion session. Kind of running out of time. But one thing I want to do is, I think a lot of times the best way to move forward is to put forward a straw man and get people to comment on that. So I'm going to do that quickly, hopefully. And can you stop sharing, Arnie? Oh, yeah. Yeah. Okay. Okay. Screen. Okay. Okay. So this didn't take much into consideration of today's discussions and things because I did this last night. So quickly, this is just a table of all the components that we kind of talked about this week and whether Multifan CL and stock synthesis has them. And I think Rick gave a good explanation of this for stock synthesis. Just mentioned that Multifan CL has generally less stuff than stock synthesis, except for say the spatial and the tagging, which it was kind of designed for at the start. But the main concepts here is that we really should be coding the new model in RTMB for a number of reasons. Seems as though random effects are pretty easy to put in, so we should have them. I don't think close-kin microcapture is at the stage in Tuna assessments that we really need it in the short or medium term, and it will make things complicated. We need to include tagging data in the model because that's what we have. We don't have surveys and stuff. We need some scalable spatial structure. We don't really need to include length-based dynamics, and we want to use a focused development approach and a single stock assessment program. Okay, so I'll just quickly go through first some underlying assumptions about why these decisions might be made. First of all, we're probably going to have limited funding. We also have a limited number of users given its Tuna assessments. We're mainly going to have contributors from stock assessment people. We really need to include the tagging data. And it's mainly for a short to medium term use as opposed to a long-term big project, partly because of the funding and stuff. And to make it successful, we want something really simple. If we go complicated, then it's more likely not going to be successful. It'll take way too long to implement. Don't really need to add anything here about random effects. If we use RTMB, they're automatic. So, and we need them for time varying selectivity. Again, I mentioned about close-kin microcapture. There's a few applications. Each of the applications are probably going to have their own little bits and pieces we've got to deal with, and spatial models will make it even more complicated, and that's kind of one of the main things we want for Tuna assessments. Yeah, talked about that. The scalable spatial structure, I think, is very important because there's a lot of different reasons space is important, like ontogenetic movement. You've got advection diffusion for most species. The non-mixing of tags, I guess, is the big one. But the spatial requirements might be different for each application. And because of the need for the fine-scale spatial temporal model for the tagging data, we might need that scalable spatial structure. I don't think we should include length-based dynamics because it makes the model more complicated. We don't really have any age length data anyway, so we're not going to be able to estimate anything. It's unlikely, I'm not 100% sure about this, but it's sort of intuitive feeling for me is that it's not going to have a bigger impact on tunas, particularly if we're managing them at reasonable levels, unlike what we used to do. And spatial variation of length or growth rates is a problem, but if there's large differences, then we should be modeling separate populations anyway. If there, and also if there's small differences, when we have good tagging data and model it correctly, we want to have less weight on the length composition so that variation, spatial variation in length and growth is not as important. We want to use a focused development approach because basically we have limited funding. It's more efficient so we can get things done faster. And probably the biggest thing is it's much easier for us to organize it. And because we don't have a lot of funding, we're not going to have a lot of people organizing it. So it's going to take a lot of time. Using a single stock assessment programmer, partly because we're going to be programming at RT&B, and so most people that know RT&B are probably assessment people. Again, it's cost effective. We don't have to pay $1 billion to a good programmer to do it. We can pay $5 to a stock assessment programmer. Because we're trying to simplify everything. We don't really need a super efficient programmer that does everything in a way that's so flexible and stuff like that. We also want code that's human readable, well, maybe not human, but fishery stock assessment scientific readable. And that will allow more stock assessment scientists to actually contribute. But I think the biggest decision we have to make is this one, is whether or not we need fine scale spatial temporal dynamics in the model, because this actually will help you decide a lot of the other questions, right? And then part of the reason the way to answer that question is whether or not we need to integrate the tagging data inside the model, or can we analyze it outside? If we go with a fine scale spatial temporal model, is it computationally feasible? Do we need to do anything different from Seppodyne? Because Seppodyne seems to work. It's computationally feasible. And then on the other side, why are the 80 move calculations so complicated? When I say so complicated, is that the initial analysis was computationally intensive, and Anders and Tobias had to use alternative approaches to make it efficient, right? Do we need this fine scale spatial temporal dynamics from anything other than the tagging data? I mean, do we need to model the local depletion? Do we need it for mixed stocks like an Atlantic bluefin? Do we need it for management advice, such as the ABNJ and 30 by 30, which is something that's going to be around the corner? And do we need it to model spatial variation in the length comps? So if we don't need the fine scale spatial temporal model, can we just use something like SAM or WAM, which has random effects in it and are fairly well developed? And do we need more simulation studies to decide these? And finally, why don't we just go for a fully length-based model and solve half our problems by doing that? So that's kind of a straw man, and then a few things that we think are pretty important to work out before we make the decision on what to do. So does anyone have any comments or questions or anything? Sorry, I went through that pretty fast, but we don't have much time left.
Paul Hitler has a comment.
Paul. What happens as funds for tagging data dry up? Yeah, you probably don't want my answer on that one. Okay, Darcy.
Yeah, I mean, do you need to decide on fine versus coarse spatial scale? Can't you just write the code to be general enough to define as many areas as you want? And then, you know, basically, I think what you're talking about when using, say, a fine spatial scale model is just the priors and the likelihoods. And so it's just how to deal with that. And that stuff could come later potentially as well. I presume you're going to need coarse spatial scale no matter what. So I guess I just don't see it as that big of an issue to make it fine if you need it to be. But that's in terms of all of the dynamics, I suppose, not not something more sophisticated like only doing it for tags. So yeah.
Yeah, I mean, it's a good question. From Tobias's stuff, I noted that he said that it doesn't work for coarse scale models, so you'd have to probably do something else as well to make it work. I think Ina said the same thing. There are some questions about how to go about making that scalable spatial temporal.
Would that not just be changing the way a likelihood works or the parameters are set up? Moving from simple movement parameters to something more complex by just switching a likelihood on or off?
It could be, yeah, or even just a specification of the movement, how to.
Yeah. Okay, thanks.
I don't know who has done that and what the advice is, whether SPM or any of the other models do that. Rick, do you have a comment?
Yeah, you include here, do you need more simulation studies? So one that I think you could do easily is to make a serious effort to look at length-based dynamics using your existing tool. I mean, use the SS3 with platoons. I feel as though you have some bias in your L infinity estimates for growth, and it's because you're ignoring this. That's a conjecture, but it's easily tested with this system that you have. And so I think you should put some energy into that before dispensing with the idea that you need to deal with length-based dynamics. Certainly with all the targeting of large fish aggregations that have happened with the longline fisheries, there's plenty of potential that the mean size and age of the population are affected by that. And I also, think given today's discussion, like you said, happened after you wrote these, I really think that there's opportunities to partner on this that I don't know that you want to give up. You seem to be setting yourself up for only a short-term solution. You already have a short-term solution for many of these things you want to do with this software that's already available.
Well, actually, I disagree with that because the biggest problem we have is the tagging data, which is not really dealt very well with the current software. I guess.
But fixing getting somebody to partner with fixing up, to improve the SS3 code for tagging is within reach. We just have never had anybody who is really under the hood on tagging for SS3.
Well, the thing is the fine scale modeling of the tagging. I mean, basically putting the current tuna tagging data into large box models is
okay. Fair enough.
Is not the right thing to do. I mean, but doing it outside and then estimating movement and putting into stock synthesis is something that's possible, right? And might be the best thing to do, but we're not 100% sure at this stage if that's the best way to go, or to go more of a dedicated fine scale modeling environment for tunas. David?
I wonder whether you're envisaging that if you go to a fine scale model so that you can explain better the observations or extract information from the tagging, you're also talking about having some of these synoptic environmental variables that are driving a lot of those dynamics and that are using Sipodin. Is that what you're talking about?
No, I mean, well, it is one option for doing this fine scale spatial temporal modeling. The other approach is what Tobias and Anders are doing, which are specifically designed to deal with the non-mixing in the tagging data. Mark, you have a comment?
Yeah, I think what Rick said just now about these points were written before today's discussion is quite salient. I personally don't mind whether you try and put close kin into the near term or not. You will be. It's already part of two big tuna assessments, and in, I don't know, 2 or 3 years, it will be presumably part of that South Pacific albacore one as well. So, you know, be careful not to rule it out for the future, I would say. But we obviously have a lot to learn there. But the real point I want to make is to reply for the third time to your question, should we just go fully length-based? And the answer to that is no, you shouldn't. There's all sorts of dynamics, as we heard today, that do depend, you know, where you have varying growth in space. We have climate change. So, you know, the oceans are going to warm up and be more acid. And so God knows what's going to happen to growth in future. And you would actually close the door to any close kin if you went down that route. So, you know, I presume a big part of this is to leave the door open for scientist readable code for other people to be able to contribute bits in RTMB and so forth. So, you know, you shouldn't go fully length based. Solve that one. Thank you.
So, Mark, just about the close kin mark recapture, if we go spatial in our stock assessment model, that, from what you were saying in your presentations, was that makes the close kin really complicated. And so,
well, what I'm actually saying is it can do, but that's quite conditional on how you decide to do your sampling and which species biology you're dealing with. So if you go back to what Rich Hillary was saying about the Indian Ocean yellowfin, if you chop the Indian Ocean into 4 blocks and the fish just drift around doing tuna stuff without any particular sort of affiliation, it's not complicated, and that could go in straight away, and that might serve as a default tuna model that's adequate for, say, specifically the tropical tuna groups, possibly albacore as well. We'll find out. It wouldn't cover the bluefin situation, but you're not trying to cover bluefin. So you could build in that default, that kind of default spatial structure, pretty coarse blocks. I think we could probably handle the length stuff in it, but need a bit of thinking. But if you wanted the full complexity of bluefin, then you couldn't do it. And you do have to control where your samples come from. Does that get at it?
Yeah.
Question? Yep.
It hasn't convinced me yet, though. But I got a reason for that. Arnie, you have a comment?
Yeah. I'll chime in because I raised my hand just about this point. So, yes. So something is becoming somewhat clear to me that was not clear 3 days ago. So thanks to this workshop, is that I'm starting to believe that maybe we will focus on 2 sort of directions of development. One would be a general package, general software for skipjack, big eye, and yellowfin tuna, the tropical tuna. A general software has many benefits that were highlighted by Rick, and I know that Mark has basically chosen SS3 for exactly those reasons, that the reviewers know what they're doing. We can collaborate much better. There are many great benefits for doing our tuna assessments in using the same software as opposed to bespoke software for every single stock. But I think albacore, we might go with a bespoke CKMR centered development that will hopefully piggyback from where Southern Bluefin Tuna already has gotten, if they go open source. And it will also conveniently align with the preferred sort of development paradigm of both Mark Brimington and perhaps Darcy in some sense, to go bespoke and sort of minimalistic on that stock, on the CKMR assessment of Southern Pacific albacore, where we are, it's a joint assessment with IATTC. So we have yet to make any decisions, but at least this would be my early or sort of initial, preliminary proposal at this point, is to aim for general software for the other stocks and for the tropical tuna, and bespoke for the CKMR, and slightly different timelines, perhaps. They wouldn't have to be in the same software author, but we should make sure that the CKMR software for albacore doesn't become sort of a secondary objective or a second priority. It must also be prioritized.
Andrea?
Yeah, I just wanted to make the comment of something that I've observed in developing FIMS is that there is a trade-off. There's been some conversations this week about code complexity, and I think Jim Thorson earlier this week said that writing the mathematical equations is simple. And I would agree, like the math is simple, but the architecture needed to support extensible modeling is what gets complicated. And so that's just something to keep in mind as you're trying to parse out how to develop like a simple versus a generalized model, because I think there is a trade-off there.
Okay. Any other comments? Yeah, so Dan gave mentions about doing the two-step approach that's estimating analyzing the tagging data outside the model. You end up getting some inconsistencies among assumptions and things within the models, and also fits to age and length comps and things like that. So doing it inside the model is generally better if it's computationally and estimationable feasible. David?
Yes, I was just going to make a comment on Arnie's suggestion of going one route with the tropical tunas. I just wanted to put on the table.
We can't hear you. You're quite.
Sorry, can you hear me now?
That's much better, yeah.
Yes, thank you. That I was going to mention that at least in my perception of ICAT, is that their main worries in tropical tunas are the interactions between the three species. So I know that was mentioned as one of the things that SS cannot get to. I don't know whether FINS can get to, but certainly it is one of the challenges that the assessment that we face in the assessments, the interactions from the point of view of those fleets that harvest the three species together. Thank you.
But that's a technical interaction, right?
Yes, technical interactions.
Yeah.
And the reason for that is, as you probably know, we're trying to develop a multi-species MSC for the management of those species complex.
Yeah, I mean, that's usually easy to overcome by just simultaneous modeling of the three species in terms of like projections and MSE work. So I'm not sure if it's, maybe something to keep in mind while we're doing stuff, but it's not typically not as difficult to deal with as ecological interactions.
Just maybe to elaborate quickly on the benefit of having a bespoke model for CKMR albacore. Yeah, I think many of you already read between the lines. It's about the spatial structure, that the spatial structure of some of the tropical tuna assessments is quite elaborate with 5 or 7 regions, and that is just a major headache for CKMR that we don't really need for albacore. So there are different sort of needs of features in those two different assessment types.
Okay, well, we've come to the end of the workshop. So thanks a lot, everybody, for your great presentations and the stimulating discussions. Obviously, we're going to have to think a bit more about this as we go away, and we might, talk to different people and get feedback. So we will, I don't know, we haven't actually talked too much about what the output from this workshop will be, but obviously there'll be some kind of report that gets produced, and we'll try and update the website with all the information, recordings, presentation slides and everything. And if anyone's got any feedback, feel free to contact Arnie and I and let us know.
People saying they are going to send feedback.
Yeah. Okay, thanks a lot, and hopefully this turns out to be a good product in the end.
Thanks for the input, everyone. Much appreciated.
Thank you, Mark and Arnie.
Thank you, everybody. Thanks, Mark. Thank Arnie.
Bye.